something spooky I'll do for you. I'm just trying to give you something. I'm just trying to give you something spooky I'll do for you. I'm just trying to give you something.
Morning, BsidesLV, ground floor attendees. Hello. Hello. Let's kick this off. First talk of the day after the keynote. I'd like to welcome everyone. Hopefully you're here for the ground floor track, Detection Engineering Demystified. Before we begin, a couple quick important announcements. First, I'd like to thank our sponsors, especially Diamond sponsors Prisma Cloud and Vanta. Gold sponsors Adobe, DropZone AI. It's their support, as well as the volunteers, donors, and others that make this conference possible. Two more quick observations. First of all, we are streaming live. It's already up on YouTube. So please turn off your cell phones if you haven't already. And secondly, if you have questions at the end of the talk, we'll have a little bit of time. Raise your hand and I will bring this mic so the internet can hear you. Please welcome David.
All right, yeah, thanks everyone. Thanks for coming. This is first time at BSides Las Vegas, so thanks to the organizers for having me. This talk is for anyone who's curious about the world of detection engineering and learning a process and some techniques for building detections that are focused on identifying attacker behavior. Specifically, we're going to be looking at building detections for GitHub today, but my goal is to share some techniques you can use to improve your detection coverage for all platforms and systems that you monitor, right? Not just GitHub. This is on the ground floor track, so I'm going to try and make it, so that people with beginner or intermediate knowledge can follow along. So yeah, here's a little bit about me before we get started. I've been in IT and security for over 18 years now. During the last 8 years or so, I've kind of gone back and forth between being a defensive practitioner, defending a single organization, and working on the vendor side, doing detection engineering, threat research, building out content for SIMs and EDRs. Currently at Google, it's kind of a different role for me. It's like a blue team advocate kind of role, working on Google SecOps. And yeah, enjoy doing stuff like this, sharing research and knowledge. And when I'm not working, you can find me enjoying the outdoors in Colorado when it's not on fire. Brief overview of what I'll be covering today. So for those of you that are new to detection engineering, I'll start off by explaining what it is and some of its benefits for a company that has that capability. Then we'll look at some threat intel that provides details on an attack group's tactics for stealing data from GitHub environments. And then we'll move on to developer detection that identifies a specific behavior. And to build that detection, we're going to identify data sources, simulate the behavior we want to detect, and then develop our detection logic. And then we will look at the concept of monitoring your data pipeline, right? And testing your detections, stuff that is really important, but is often neglected by security teams, and it comes back to bite them. So I'll walk through a couple of example techniques for doing that. And then I'll leave you with some key takeaways and some links to some resources to learn more about detection engineering if you're interested. So just for the benefit of folks who are new to this, right, just want to take a couple of minutes to review what detection engineering is and some benefits. So let's do that. So I like to think of it as a specialization within security focused on implementing detective security controls. The goal is to detect and respond to potential security incidents before they can cause our company significant damage. There's a focus on continuous improvement. So a team of detection engineers have this process for continuously developing, testing, and improving your detections to stay ahead of threats. And our detections complement our preventative security controls, either acting as a safety net if that prevention fails, or it lets us implement controls where prevention is impossible or impractical to implement. There's an emphasis on detecting attacker behavior versus indicators of compromise. I'll talk more about that later, but the idea is our detections have a longer shelf life if they're behavior-based. And yeah, this term's, I think, been appearing more frequently during the last 3 to 4 years. It's now, I think, accepted as its own specialization within security. Plenty of job postings on LinkedIn that either have, detection engineer in the job title or within the job description. And just to take a second, actually, if you're, and my friend Wade pointed this out the other day when he went through a dry run of this with me. You don't have to be, your title doesn't have to be detection engineer to do detection engineering. You could be a SOC analyst or part of a, detection and response team. That could just be part of your job that you're developing these detections. A couple of slides on the benefits for doing this, right? If you're a company that has this capability, it reduces risk. So by detecting that malicious activity early on, before an attacker can achieve their goals, you've got a chance to respond before a data breach or a disruption to your business operations occurs and causes significant damage. This can not only save a significant amount of money if you catch threats early on before they cause a bigger problem for you, but can also save lives, right, depending on the industry you work in. So this study by this university at the top right, ransomware attacks are being carried out against hospitals. They found that mortality rates increased by 20%. So we're not just writing detections for fun, right? By being good at security, depending on the industry you work in, you can help save human lives. And then next, by developing these detections that generate actionable alerts, the security team can reduce the time you spend working on security incidents. So this is an opportunity, if you're responding to incidents quickly, you can build and maintain trust with your customers. People are definitely paying attention now when you go through a security incident. They want to see that you've got your act together when they bank with you or, store their personal information with you. And then final slide on the benefits before we move on to look at this piece of threat intel. So having this continuous process for identifying and integrating new data sources or logs can increase your visibility into what's happening in your environment over time. Detection engineers are continuously kind of assessing your detection coverage as new threats and attacker tactics emerge, and they're constantly kind of developing and refining their detections. And then finally, depending on the industry you work in, you might have an auditor that comes in and asks for evidence that you've got certain detections, right? So if you work in the financial services industry, you might have an auditor come in and ask if you've got detections related to Swift. All right, so we're going to move on to look at a practical example of how to transform some threat intelligence into a detection. So let's look at this. So while I was working at another company, I was on the phone to a security engineer who worked in the same industry as I did. They said they shared some intel on a threat group's tactics for stealing data from GitHub enterprise environments. So let's take a look at the details they shared, among several other things, right? And you might recognize this threat group, some of you. This is what the attackers were up to at the time. So they started off by compromising a software engineer's Okta user account via a smishing campaign. They lured users to log into a fake Okta single sign-on portal, and then they stole the user's credentials, so their username, password, one-time password token as well. Then they used the stolen credentials to log into the target's legitimate Okta portal. They were using VPN services to mask their IP address and geolocation information. And then they log into the target organization's GitHub Enterprise account via the Okta dashboard tile. And then they create a personal access token under their compromised user's account. And we'll talk more about what that means in a moment. And then they use this tool. This guy said they're using this tool called Gorge to clone all of the code repos that user had access to. So needless to say, right, after hearing this, I became interested in what logging, monitoring, and detection opportunities existed for GitHub, right? I'd never looked at GitHub logs before. I didn't know what kind of auditing was available, so we're gonna look at some of that as well. So for the remainder of this presentation, we're gonna use this threat intel to create a detection that alerts if a specific behavior happens in our environment, right, that we're defending. So just taking a minute to consider why attackers target GitHub and why, as defenders, we should care about monitoring and defending our GitHub environment. Some code repos might contain intellectual property, right? After stealing that data from an organization, an attacker might try and sell that or use it in extortion attempts against you. They can examine your source code for vulnerabilities, which they could either sell or exploit in follow-up attacks. If they're able to harvest secrets from your GitHub environment, they can use that to further infiltrate your environment, right? Perhaps they can establish persistence in one of your cloud environments. And then finally, if they're targeting a company that develops software, they can look to inject malicious code into that company's CI/CD pipeline and deliver malware or backdoors to unsuspecting customers, we've seen that before, right? So people aren't familiar with GitHub Enterprise. Here's a brief overview of some of the key concepts for this platform. So GitHub Enterprise is this commercial offering that provides companies with the tools and features they need for collaborative software development. So we're going to look at the GitHub Enterprise cloud-based platform and imagine that your organization has a subscription to that offering. An enterprise can contain one or more organizations, and an organization essentially just lets you group certain projects together for people to collaborate on. You might have a GitHub organization for each of your company's core product offerings, for example. And then these organizations contain repositories or repos, which is where the code is stored and it's worked on for each project. And then GitHub users are invited to your GitHub organizations where they can collaborate on projects. And then I mentioned this thing about personal access token, right, in this threat intel we received. A personal access token just acts like an alternative password for your GitHub account, right? So you can create a token under your account, grant it specific permissions to interact with GitHub's API. And yeah, these tokens need to be kept confidential, and people should assign the minimum necessary permissions to limit damage, right, if they're compromised. So one of the first things I did when I heard about that tool that guy mentioned, right, was to try and find it. The tool was on GitHub, ironically. It lets you clone an organization or a user's repositories into a single directory. It works with GitHub, GitLab, and Bitbucket. I found it funny, like the list of use cases includes creating backups, so the attacker's creating involuntary backups for people. So at this point, there are a few questions to ask ourselves as detection engineers. So should we review the code for the tool and try to look for detection opportunities there? Who's the developer of this tool? Do we trust them? What if the tool contains malicious code, right, to infect unsuspecting users? We definitely wouldn't want to download this and run it in our production environment and let it interact with our company's code in GitHub. So yeah, do we want to look for opportunities to write signatures to detect the tool, or do we want to build detections that detect the underlying behavior, right? So in this presentation, we're going to build behavior-based detection. So now we've got an understanding of the attacker's tactics and the tool they're using. Let's look at the differences between an indicator and a behavior-based detection, if you're not familiar with this. So we could analyze the tool and look for opportunities to fingerprint it and write signatures that detects this use in our environment. So the tool might have a specific user agent string that it uses. But with this particular type of detection, the attacker could just modify their code, right, and have it use a different user agent string, maybe one that blends in with other traffic and evades our signature. Also, the attacker might try and use a different tool, then our indicator detections might be broken, right, and they might miss that behavior. Alternatively, which is what we're going to do, we're going to focus on detecting the underlying actions that need to happen to detect the activity. So the idea here is that it's usually harder and more expensive for attackers to change their behavior instead of just swapping out their tools or malware or infrastructure. And then with this type of detection, we're monitoring for a sequence or a pattern of behaviors, which we'll look at next. And just before I move on, I just want to note, with an indicator-based detection, if you're able to deploy an accurate signature that detects, malware or an active intrusion, then that's a win, and we definitely shouldn't discount the value of indicator-based detections as well. All right, so let's move on to develop a new detection to alert us if that specific behavior occurs in our environment. So this is a very basic design, right, for the detection we're gonna build to identify a specific behavior, and we're gonna expand upon this as we go through. So we're gonna detect these following atomic behaviors in sequence, and think of these atomic behaviors as your building blocks for your detection logic. So by combining multiple atomic behaviors, you can create more complex detection rules that alert on these patterns or sequences of activity. So the first behavior is permissions being granted to a personal access token. The second behavior is that same user account being used to download more than 5 GitHub code repos. So we're going to build this simple detection, expand upon it from there. There are opportunities to detect other behaviors that were in that threat intel we received. but we're going to focus on this single detection use case, given the amount of time we have. So now we've got that basic design for that detection we want to build. We're going to look at what data sources are available to us as detection engineers. So a detection needs to be fed relevant data or events, otherwise, it will never generate an alert to tell us that the behavior happened in our environment. So in this example, we can see GitHub Enterprise has got this audit log that records events as they happen in our environment. It tells us that those logs are retained for 180 days. Git events are only held for 7 days, right, before they roll off. And Git events involve people cloning code repos, like the attacker's doing, and people pushing code to repos. So we're definitely interested in those events for our detection use case today. And yeah, in my opinion, a decent audit log when you're looking at the stuff includes details on the who, what, when, and where for the event. The why for an event is usually implied, or you need to look for another data point to tell you why the user carried out that action. So in this example, why did this user disable this setting in our GitHub organization? So we need to either speak to the user or go out and find, maybe a ticket or another data point that tells us why that happened. So yeah, in this event, we can see the who, right? Who carried out the action. There's a unique ID for the user that initiated that action. What happened? There's a specific action or event that took place. And when the event happened, we've got this precise timestamp. So the where is missing from this event, which is a location, right, from where that action originated. And let's take a look at why that's missing. So a couple of noteworthy things to call out regarding GitHub's audit log. So by default, the source IP address is not going to be in your events. I think it's some privacy thing, right? You have to go in there and enable that. We definitely want to see that. The second thing to call out is that by default, API request events are not going to be streamed to our SIM. We're going to be developing our detection in a SIM, right, from a centralized location. So we're going to enable that option too. This is going to let us see, attackers or regular users cloning the contents of GitHub repos via the API. So these are the reason I bring this up, right? These are the types of nuances we need to understand when we're looking at new data sources for detection. So by reading GitHub's documentation and exploring those settings for the audit log, we can configure it to be used for our detection use case. And just to point out, right, not just for GitHub, but if you're working on a security team building detections, or you care about logging for investigations or hunts or whatever, definitely make friends with the people who administer and own these platforms, right? They might not always have security in mind and know to turn these settings on to make the log valuable to you as defenders. So definitely build those relationships and get your data in a good state. So next step is going to be to configure GitHub to stream its audit log to our SIM for ingestion. Our SIM is going to normalize these events into a common schema and index them so we can use them to build our detection. So in this example, we're just streaming those audit logs to a Google Cloud storage bucket, and then our SIM is going to collect the logs from that storage bucket and ingest them. So the next step is configuring our SIM to ingest the GitHub audit logs from that cloud storage bucket. In this example, I'm ingesting the logs into Google SecOps. So this is, community event. My goal is to keep things as vendor neutral as possible. So, and share some practical techniques for detection engineering, so you can apply these techniques using whatever tools you use. So at this point, we've configured our GitHub audit logs, those GitHub audit log settings, and we're ingesting the logs into our SIM. So the logs are being normalized and indexed, and they're available for us to search. The next logical step is to simulate that behavior we want to detect, right? So we've got some events that we can use to develop our detection logic. There's a party going on out there when a door opens. Okay, yeah, so if you skip this step, right, it can feel like you're shooting in the dark when you're writing your detection and you don't have any events to test it against. So that's what we're doing here. So in my GitHub Enterprise environment, I created a GitHub personal access token. Then I granted that token access to 6 GitHub repos in my environment. And then I used that token to clone 6 repos. So after executing that test scenario, I went back to my SIM and explored those events to understand, the various field names and values that were logged. So you can see at the bottom in the middle, we've got the personal access token, access being granted to that. and then the git clone events above that, and then on the right you can see these events were carried out using a personal access token. So now we've simulated that behavior, we can develop the first version of our detection rule. So this example is going to be written in the YARA-L language. You can adapt this to work with the technology your company uses, right? So in the events section of this rule, this is going to specify the field names and values we want our detection to match on. So on lines 20 and 21 here, we're searching for events where access is granted to a GitHub personal access token. And then on lines 24 to 27, we're searching for events where a private GitHub repo was cloned using a personal access token. On line 28, we're just creating this placeholder variable named GitHub repo name. This is just going to store the name of the repo that was cloned. And then line 31, we're joining that GitHub personal access token event to the GitHub clone event based on the user ID, right? Because we want to join those by ID to see which user is carrying out the activity. And then on line 34, we're creating another placeholder event. This will become clearer in a minute, just to hold the user ID that carried out the actions. And then finally, on line 37, we're searching for events where that personal access token event happened before the repo clone events. So reviewing the other sections of that rule, the YARA-L rule, in the match section, we're telling the rule to return results if the events we specified are found for a single user within a 30-minute time window. In the outcome section, we're storing the count of distinct private repos that were cloned. And then finally, in this conditions section, we're specifying that the rule should trigger if a match is found for those events and more than 5 GitHub repos were cloned. So now we've written the first version of our detection rule. We should test it. To do that, we could either run our detection logic over the events we generated earlier or simulate the attacker behavior again. In this example, we can see a user created a personal access token, and then they cloned 6 distinct private GitHub repos. So our initial detection logic works. And then let's assume that after testing that new detection, we handed it over to our SOC analysts to respond to alerts. And then after a week or so, they tell us, it's generating false positives. This is taking up their precious time, so we need to fix that. So let's say, hypothetically, in this organization, when a software engineer gets a new laptop, it's common for them to create a new GitHub personal access token and then clone all the private code repos that they work on. So we're going to look at an option for filtering those false positives and increasing the detection's precision. We now have time to do a deep dive on precision and recall and those classification metrics that can be used to measure the performance of your detections. But if you're interested in that, you should definitely check out the link on this slide. So if you recall, our threat intel said that the attackers are using VPN services to hide their IP addresses and geolocation. One way for us to filter these false positives is going to be to modify our detection logic to generate an alert if the activity comes from a VPN service, right? So when I spoke about precision, it talks about considerations when you're filtering false positives, but you might in turn introduce false negatives or misbehaviors. So in this example, let's say that our users should only be using our company-approved VPN, right? Not Molvad VPN or NordVPN. If we move forward with this tuning option, we could create another detection that looks for activity from non-company approved VPNs or looking for installation of those VPN clients on endpoints. So yeah, to tune this detection, I'm going to use a third-party data feed from Spur. If you're not familiar with them, they provide data feeds on VPN services, right, residential proxies and bots. And the value there is that the IP addresses for these services churn quite quickly. So an IP address that's for NordVPN might not be for the same service, might not be being used for that next week. So having these kind of up-to-date feeds is useful for correlation during detection and investigation or enriching events. So in the highlighted portion of this screenshot, we're modifying our detection logic to match on the GitHub activity when it comes from an IP address that Spur attributes to a VPN service. In this example, we're joining the IP address from the GitHub events that we enabled in our logging, right? with an IP address in Spur's data feed if it exists in their data. And this is an example of how we can use third-party data sources to adjust the precision of the detection. All right, so when you're developing and tuning your detections, it's crucial to test them after any modifications are made. So in this example, I went ahead and simulated that behavior again in my lab environment and validated that the detection generated an alert. So on the left, you can see the detection matched on the same GitHub events as earlier. And then on the right, you can see Spur is telling us that this IP address is associated with the Molvad VPN service. And yeah, if you're not familiar with that, they accept cash and Bitcoin as payment methods. It's popular for people wanting to do certain things and attempting to remain anonymous. So definitely weird, right, if you see that in a lot of environments. Slide 29, and I haven't mentioned Gen AI yet. You almost got away with it. One of the important steps when developing a new detection is going to be to document it, right? This ensures that the goals and the design of the detection is understood and the team knows how to triage and respond to alerts. We could have done this earlier, right, arguably, but we're going to go ahead and do that now. A popular method for documenting your detections is to use Palantir's ADS format, alerting and detection strategy. And Whois, who I think is in here, he's a lead detection engineer. He's built this AI assistant that helps us document our detections, right? So in this example, we're asking the assistant to document the new GitHub detection. We provided some details on what behavior we're trying to identify and the data sources the detection relies on. So the assistant responds, right, with the documentation for the detection in ADS format. It documents the goal for the detection. The MITRE attack technique mapping was incorrect, so we'll have to fix that. But it includes, technical explanation of how it works, any blind spots, how to validate and respond to alerts, and so on. So the output's not perfect, right, as with a lot of these LLM models at the moment, but it saves us a lot of typing and can help us document out, speed up our workflows as detection engineers. So encourage you to check that out if you think it might be useful. All right, so let's move on to look at why we should monitor this data pipeline we've built and a technique for doing that. So this is something that's often neglected or not thought about, and it comes back to bite you as a defender. So simple diagram of the data pipeline we've built so far. As you can imagine, this will get more complex as we integrate additional data sources with our SIEM. It's going to be important for us to monitor and test the various components in this pipeline as our investigation and detection capabilities rely on the quality of our data. So on the left, we've got GitHub audit logs and those Spur data feeds I mentioned. In the middle, we've got a couple of services running in Google Cloud, right, that are helping us ship this data from the left to our SIEM on the right. And when data is shipped to our SIEM, it's typically normalized into a common schema. Then it's indexed before those events or records are searchable. Those events might be enriched either before they go into SIEM or after, maybe with metadata about an employee, like their job title or department, or geolocation information for IP addresses. And then those events are available to the detection engine to run our rules over those events and generate an alert if a match is found. So all of these components and connections in our data pipeline can fail, which is why it's important to be able to monitor for issues and jump in quickly and fix those. So as an example of a failure, right, GitHub might stop shipping its logs to the storage bucket, but our SIEM is checking the storage bucket every 5 minutes for new logs. It doesn't find anything. It doesn't see an error. This is like a silent failure, right? And then when something bad happens in your GitHub environment, you won't see it, or you need an investigation, or you start an investigation, your logs aren't there for you. So let's look at how to do that. So some reasons to monitor your data pipeline. So our environments tend to drift over time. When you configure a data source and write some shiny new detections, everything might be working fine today, but that might not be the case in a week or a month's time. So infrastructure and technologies come and go, system configuration changes, software's updated. All those things can impact that data pipeline that we looked at a minute ago. Monitored systems might stop logging, or somewhere along the line their logs stop making it to our SIEM. Logging spikes can cost a lot of money if you don't jump in, or identify and jump in and fix those quickly. The SIM might have issues parsing events from the logs it received, so maybe the vendor, maybe GitHub changes its logging schema, and our detection relies on a specific field name that's changed, and our detections fail. And then, yeah, latency issues as well between certain components can result in us, behavior getting missed or logs not being available when we need them. And yeah, a lot of these things can result in, missed behaviors, false negatives, missed opportunities to detect and respond to threats early on. Anyone experienced any of these issues affecting their detections? Yeah, okay, sucks. All right, yeah, so just a quick call out here. If you're interested in learning more about data pipelines and how to monitor and improve your data quality, I highly recommend this talk by Josh Liberty. All right, so an example technique, right, to get you thinking about monitoring this stuff. Techniques to monitor some components of your data pipeline. So we need to know when there are issues with that pipeline so we can jump in and fix it before our detections are impacted. Some people like to create detections that alert them when a system goes quiet, they stop seeing logs in their SIM. That can be fine with like a noisy platform like Okta or Google Workspace. But some systems are just quieter than others, right? Just because it doesn't log 1,000 events an hour doesn't mean there's a problem. So what I've seen is those detections can create false positives that just waste more of our time. Another option is to think about implementing these health checks for the systems and data sources that are important to us. A health check can carry out a small basic operation, a read operation against the monitored system, and then validate that those events are in your SIM and they're indexed and searchable. So these automated jobs, you can just run them on a schedule in your automation tool or CI/CD pipeline, whatever you use, and they can alert us to any issues that occur. So they don't have to be anything complicated. Let's look at an example. So here's an example of a health check that we can use to monitor for issues with our GitHub audit logs being ingested into our SIM. So I've just created a couple of GitHub actions for this example, GitHub actions jobs. And you can put these in whatever automation tool you use. But yeah, this first job is scheduled to run daily. You could run it more often if you like. This example is just making an API call to GitHub just to read the information for one of my GitHub organizations. It's just a simple read operation. We're not making any changes. And at this point, if authentication or the API call fails, an error will be raised and we can jump in to take a look and investigate at that. So this first job passed. The second job runs after the first one. It's searching for the events that we expect to be generated and indexed in our SIM based on that first health check job. So we're running a search query via the SIM's API. We can see in the output of this job, we're searching for those values of specific events that we expect to be there. One event was returned in this case, and our job completed successfully, right? So if that failed, we could jump in and fix that issue before it impacts our detections or other security operations. So it's not a comprehensive solution for monitoring all components of your data pipeline, right? We didn't talk about latency between log events being generated and when they're searchable in your SIM. But hopefully that gets you thinking about monitoring these things. You can get started with some minimal code, and it helps you not get blindsided by missing attacker behavior or red team activity, finding out that you don't have any logs to support your investigation. It sucks, right, when you're under pressure to figure stuff out. Let's look at the importance of testing our detections on a regular basis and an example of how to do that. So this is another step that's often skipped by security teams, and it comes back to bite you again when your detections are broken and you don't know about it. By testing our detections on a regular basis, we get to say with confidence that our detection and alerting capabilities are working properly. So a few common issues that impact detections and might sound familiar to you. So a system might stop logging events, or the events that are being shipped to the SIM might not be parsed properly. Data sources might be misconfigured, right? We looked at our GitHub audit log. If those two settings were turned off, we wouldn't see IP addresses or API calls. Our detection would be running, right? But it would never fire. And pesky vendors, right? Changing their logging schemas on us. Spoke about this earlier. If the field name changes, our detection might break. And yeah, if you're running if you run your rules in detection engines that are never going to fire, we're wasting resources, right? So yeah, by implementing automated tests, we can be alerted to issues and fix them before we misbehavior. So looking at an example of how to test that new GitHub detection we created earlier, we want to test the detection regularly, maybe once a day, and be alerted if the detection doesn't generate an alert. In a perfect world, right, where we would create a test that simulates that attacker behavior end to end and validate that an alert was generated. In this case, right, this isn't realistic for a few reasons. To my knowledge, we can't create a GitHub personal access token via their API and configure it with permissions. We probably don't want to do that anyway, right? We've got a test, maybe it fails, we don't want to leave these tokens out there dangling with permissions assigned. It's just not real world. We probably also don't want to develop a test that comes from, Molvad VPN service and interacts with our data, just for the sake of testing this one detection. And yeah, finally, developing tests can often take longer than writing the detection itself, right? So is it worth the effort to develop an end-to-end test that does all this? So probably not. Let's look at an alternative. A practical technique is to take the events we generated earlier and then replay them to our SIM for ingestion. So to do this, we've got another couple of GitHub Actions jobs that run on a schedule. The first job replays those historical GitHub log events into the SIM for ingestion. We're modifying the timestamps so that it's today's date, right? Because generally our detections are only looking back so far in our logs when they're running in an engine. And the events are also labeled to make it clear they're related to testing activity. So in this example, we loaded up 7 events from this JSON file. We shipped them to the log for ingestion, shipped them to the SIM for ingestion, and then our second job is going to validate that the detection generated an alert. So in this example output, this second job checked for any alerts generated by our detection, and 0 alerts were found and an error occurred. So this is an example of the job failing, right? And this alert will come to us so we can jump in and fix whatever it is, right? Logging, maybe there's an issue with the detection engine or something else entirely. Here's an example of what it looks like when that second job passes or completes successfully. So the job found 1 alert that was generated by our detection. It validated the alert was generated by testing activity. It looked at this label, log replay equals true. If you have alerts opened up in your SIM or your case management system, you can look for that flag as well and just close them out, right? So analysts don't need to spend their time looking at them. And yeah, this approach can be applied to other detections. You could start small and test 1 detection per log source, right, that you care about and that you're ingesting into your SIM, and expand it from there. And a risk with this example, right, is that you probably thought of this as I was explaining it. GitHub could change its logging schema. We're validating our detection against older data, right? This is far better than having no tests at all, because we're testing the components of our SIM, detection engine, that kind of thing, ingestion. But you could commit to refreshing your test data every few months, right? Or commit to testing the detection manually end to end on some agreed upon schedule. All right, so that's, we're at the end here. Let's summarize or leave you with a couple of key takeaways and then some links to resources you might find useful. So if you're new to detection engineering, hopefully you've seen that this is a proactive capability focused on identifying attacker behavior. Your security vendors might provide you with out-of-the-box detections, right, that are quite generalized. They don't want to blow up their customer base with false positives. No one knows your environment better than you do, right? So you can start diving into analyzing attacker tactics, developing custom detections that are accurate, right? And you can detect malicious activity before it causes harm to your business. We spoke about the importance of monitoring your data pipeline and testing your detections. So this lets us find issues before we miss any attacker behavior or find out that our logs are not there when we need them. And yeah, if you're not doing any of that kind of monitoring and testing, just challenge you to start thinking about how you can implement some of that and get started with some minimal code and automation. And then finally, I didn't speak much about the skills and experiences required on a detection engineering team, but I think it's important for a team to have this diverse skill set, right, to build the best detections. Haven't met a 10x detection engineer yet. It's not realistic to expect that one person can bring everything to the table, right? So something to bear in mind if you're building out a team and recruiting. And then finally, links to some useful resources. I wrote a blog post recently about getting started with monitoring and detection for GitHub. It includes 26 free rules to help you get started. My colleague John Stoner gave a presentation recently about strategies for testing and validating detections. Wade's AI assistant for documenting detections is here. If you're interested in a different perspective or a deep dive on a different detection engineering workflow, Dan Lucier's got his blog post. If you have a training budget, SpectreOps detection engineering course is awesome. You should check that out. And then finally, Megan Roddy's book gives you a good intro into the world of detection engineering with practical examples. That's it. Thanks for coming.
Any questions?
Do you have any recommendations on tools that smaller organizations could use to implement some of this?
Yeah. Anything specific, like a SIM or the testing part, or?
Mostly the SIM aspect.
The SIM aspect? Yeah, I would, trying to be careful. I work for a vendor that offers a commercial offering. Just Google free or community editions of SIM, and you'll see some popular solutions out there, right, that offer a commercial solution if you get to the stage where you need to pay for support and, I don't know, maybe more log ingestion, like capacity, that kind of thing. So yeah, just Google that, or we can talk in the hallway after.
Anyone else?
Sorry, buddy. Sorry about that.
That's all right.
As a factor of age of a security program, so by years, I'm kind of curious, what is your expected time to turn out a detection? So I'm kind of working on the assumption that a security program in its first year is going to be a lot slower to turn out a detection than a security program in its 10th year. And just kind of from your experience, what's a good goal to shoot for based on that?
Yeah, it's a tough one. It can vary depending on the complexity of the attacker behavior you want to identify. I don't know, I'm trying to think of a recent example. So if you had, I don't know, Okta session cookie theft as like tactic of the month, right? It's the hotness, all the companies are getting breached. You can quickly either simulate that behavior using open source tools, right? Or if it's a popular technique in the industry, other people are churning out detections. So you could get something going probably in like an hour or two in that case. I think it's, more the, tuning for false positives. The testing can take a long time. But what do you think, Wade? Just an emerging threat and then getting a detection out quickly,
I think it depends on the organization, right? If you're a huge organization, one of the struggles is actually knowing if you already have a detection for it. If you're, I think you said a new organization, that's a year old, I would say it's almost easier because you know what you have and you don't have. But the harder part is the harder part is actually passing the knowledge of what the detection is. And building and testing it, like you said. Writing the query is the easy part. I think everything else after that is the hard part.
Yeah, and figuring out if you actually have the data available to write your detection.
If you actually have the logs, if the logs are coming in from the right spot, if they're set up correctly with the configuration, like you said.
Yeah, and then there could be red tape in your organization to get those logs ingested and that kind of thing. So yeah, if you've got the logs, you can maybe get a prototype of a rollout in an hour or two. Yeah. Long answer.
Well, thanks so much, David.
Yeah, no worries. Thanks, everyone. Thanks, Eric.
this will I do for you. I'm just trying to give you something.
Morning. Welcome back to Ground Floor, BSides, Las Vegas, 2024. This talk is Adversaries Also Lift and Shift. Before we get started, a few quick announcements. First of all, I'd like to thank our sponsors, especially Diamond sponsors Prisma Cloud and Vanta. Gold sponsors Adobe and Project Circuit Breaker. It's their support as well as other donors and volunteers that make this event possible. Secondly, cell phones. We are streaming live. Please turn them to silent. And third, if you have questions at the end of the talk, please raise your hand and I can bring this mic over so everyone can hear you. With that, please welcome Adi Bell and Calvin Sherman. Thank you.
My name is Adi Belinkov. I have experience of 12 years in cybersecurity. Before moving to cybersecurity, I worked as software engineering for 7 years.
Hi, my name is Roy Sherman. I'm the field CTO for Mitiga. I was doing offensive security for the last decade, and now I moved to defensive. I have a bachelor's degree in information security and a master's degree in criminology because I have a thing for bad guys. Part of the BsidesLV organizing team and amateur homebrewer. Let's start.
When we talk about the cloud, it doesn't just the cloud provider. We also include any system or application that provides services in the cloud. You can see here the trends in the SaaS market. The number of the SaaS companies and end-user spending on public cloud services is expected to increase, which is why we are focusing on our attackers are adopting their strategy on cloud attacking. There's several good. Thank you. There's several good reasons why companies moving to the cloud. Companies can reduce spending on purchasing and management hardware. The maintenance, it's much easier. It allows organizations to adopt new technologies. The downtime is very low, and enable businesses easily to scale their resources up or down based on current needs. However, it's important to note that security is not one of the reasons behind this shift. The number of attacks on the cloud also increased. Those systems have become attractive targets for attackers. The very large volume of sensitive data and critical business processes being handled by SaaS applications make them high-value targets. Cloud applications are internet-facing, which make it easier for attackers to find weaknesses and exploit vulnerabilities, compared to on-premise applications that are protected by additional layers of security, such as firewall or VPNs. Let's talk about this use case. It's very familiar. A Russian cyber group called Midnight Blizzard attacked Microsoft by using password sparing attack to access a legacy non-production test tenant accounts that didn't have MFA enabled. And moving to the main Microsoft corporate production tenant, and by that, they access to internal systems and also source code. If you're not familiar with what is password sparing attack, it's a type of brute force attack. So it means that all the attacks that perform over there are very known, simple, and very easy. Everything was cloud only. Microsoft are a big cloud provider and still miss this for months, like you can see over there. Microsoft invests a lot of information information security, but still had a misconfiguration issue in the cloud. As I already know, that both companies and attackers move to the cloud. Now, let's see the differences between clouds, attack and defenses. What is the difference between cloud and on-prem? You can see here that attacks are much easier on the cloud, and defense are more challenging. This table shows high-level overview of the differences. Sherman will dive in each or one of them.
All right. So we see that even big companies like Microsoft still struggle both with the basic security in the cloud, even though they are one of the main cloud service providers. And we can also see that attackers keep focusing on cloud. We had Snowflake very recently, which was only a cloud-only attack. But we'll start with the attacker POV, which is my favorite POV, to be honest, to go through each one of the items we mentioned, each one of those topics, to talk a bit about how it looks from both the attacker and the defenders. So from the required skill set perspective, we know that when you attack an on-prem environment or technology, you have a lot of the basic computer knowledge required, like basic networking, subnetting, how things work, protocols, SMB, NTLMs. You need to even have a basic understanding on how to compile and run exploits. Everybody that went through the OSCP courses saw that we struggle a bit until we figure out how it works. We have ExploitDB. Now we have Gen AI and all of those fancy things, but still, you need to have some sort of basic knowledge and understanding how things work before you can come in and start breaking them apart. You have a lot of technology you need to learn how to bypass. One of the most common topics discussed today for red teamers is how to bypass EDRs. You have whether it's unhooking and other different types of techniques, and almost every other week somebody comes out with a new tool or a new technique against EDR. And eventually, even if you're targeting the database of a company on-prem or their application or whatever, it works on a computer or a server that has an operating system. So whether those are Linux or Windows-based, you still have an operating system you can either target or interact and try to fight with. On the other side, in cloud, everything has a UI. Everything has a portal, fancy buttons you can click. You don't need to have very deep internal knowledge on how those services work or operate if you want to interact with them. So if you want to download an entire AWS bucket, you just have a checkbox you mark and click download. That's super easy. Also, everything is available over APIs because cloud was made to make IT lives easier. When you want to orchestrate stuff, when you want to deploy things, everything has an API. So interacting with it is very straightforward, has very good documentation. And we have wide misconfigurations that are super common. I'm personally familiar with over 20 different open source tools that target AWS buckets or Azure storage accounts or GCP storage. All of them target the same things. Publicly accessible with anonymous access that you can do pretty much everything. So we mentioned a few tools, and that's the thing. Tools are something easy to burn or to mark as a defender. You either get signatures, you either get how they operate on-prem, what they target, what they do, what they execute. So from a defense perspective, Mimikatz probably gets an update twice a day today, but still we get those signatures from our defense tooling and our security structure. We also have the C2 frameworks, but those now come with a cost. Some of them are open source, which are a bit harder to maintain, harder to use if you're less experienced. But if you want the top tier, you need to pay money. And it's not very easy because those, when you pay and you need to have a license, they try to crack down on the threat actors that are using them for malicious purposes, which makes it harder for criminals to obtain them unless they go for the pirated version, which usually is much less secure for them. But for us, the red teamers, the pen testers, we have Mimikatz, which is commonly available and everybody already knows how to use it. We have the end-day exploit. So when CVE comes out, usually in a few days, you'll have a working exploit somewhere, and you have those frameworks that collect all of those exploits, so whether it's Metasploit for the legacy folks out there, but also other options. In cloud, it's very hard to defend against those tools because you don't really have a hash. You don't know when somebody is running a specific tool against your infrastructure because, as we mentioned, everything is tied to the API. So those tools to attack cloud are basically somebody that's coding how to interact with specific APIs in a specific order to automate those types of activities. And as an attacker, you don't really need or use a 0 day or an end day unless you're a state nation or something like that, because you don't really need it, and it will target the actual infrastructure, which is much harder to exploit and compromise rather than specific services that probably are misconfigured by your victim. The security tech stack. So a lot of acronyms, I'm sorry, that's the industry we live in, but in on-prem, we have many. We have the EDRs for the endpoints. We have IPS and IDSs for network, NAC for the physical connection, internal firewalls for segmentation. We have bidirectional firewalls. We have a lot of different technology that we are already familiar with. A lot of the companies already bought over 100 different types of security tooling for their on-prem, where in cloud, we're only starting. So we are all familiar with the CSPM because they almost sold for Google for like $23 billion. But we have some common acronyms. To be honest, we're doing cloud for a living. We don't remember all of them. I had to Google some of them to put them in the slide of what they actually mean. But the common theme for at least the top 3 of them, it's security configuration. They look at how are you configured and not how you are actually ready to do something, detect something, or respond to something. The last category, the TDIR and the CDR, are looking at that portion to see, all right, we have the configuration thing sorted out-ish, and now we need to see what we do for actual active defense. And the perimeter. That's something everybody already heard of, that the new perimeter in cloud is identity. It's a cliche, it's funny, but it's still true. Because when you want to get your initial access and you want to compromise a company or target their on-prem infrastructure, you need to get a foothold within the environment. So whether it's phishing and you need to land with a malware on the host, or phishing for credential and you need to find a way to remotely connect, whether it's Citrix, VPN, any type of remote connection into the company, or you can find a vulnerability with one of their external footprints. So whether it's an unpatched service, shadow IT somebody forgot about, or something you need to compromise, or for some of us, that's the favorite way, physically get into their offices, plug something into the network, and then you have that access. So you have that actual step of breaking sort of a boundary in order to get into the company. So it's not necessarily more difficult, but it's still more work. And we already know that hackers are lazy. That's what makes us good at what we do. So we'll try to have the least amount of investment on our side to get the biggest amount of value. In cloud, all you need is identity. And it doesn't really matter if it's a human identity, like username and password and MFA fatigue or no MFA, or just a non-human credential, an API key somebody forgot in one of the commits in GitHub, or anything you managed to get from a different company. At the end of it, we'll talk about another use case where a company was breached using a non-human identity, and then what was stolen from them are a bunch of non-human identities for their customers, which makes this cycle much more vicious. So attackers stopped from breaking in, we started to log in. And talking about detection, so as we mentioned, where we talk about on-prem, we already know sort of what's suspicious. So, sorry? Yeah, thank you. So everything that interacts with LSAS that's not common, we already know it's weird, it's suspicious, it's something we want to look at, it's something we want to block. We have the signatures we mentioned, we have the old technology, all right, NTLM, or in some cases LM. We have technology designed to identify when exploits are running through the network. Fancy ways for extracting information, whether it's DNS that's uncommon, anomalies, stuff that's out of pattern. In cloud, every activity the attacker takes It's the same activity as an admin or a developer would take. The only difference would be their intention. And currently, it's very, very hard to build detections for intent, because in the end of the day, you might have anomalies, but every organization is different. And as a defender, you also want something that's tailor-made for your organization, but when you work with a community, everything has to be generic, so everybody can adopt it. So it makes it much harder for us to improve our detections in the cloud, because somebody replicates a cloud or a storage account. We don't know if it's an attacker replicating it for an unplanned backup they're gonna do for us, or it's an actual IT guy doing their own backup routines. People adding integration apps, whether it's Slack, code repositories, whatever we have today that's integrated with SaaS, whether it's something they want, need, and approve to do, or is it something an attacker puts in to have additional access to our infrastructure? Somebody spinning up huge GPU instances in the cloud, they might be playing with generative AI, they might mining cryptocurrency. We need to figure out which use case is it. And of course, the creation of non-human identities. We have developers building CI/CD pipelines or building automations, but we also have attackers creating backdoors and persistency for themselves. So we had all how it looks from the attacker perspective, but we're here to talk about also about defense. So same structure, same things, but from the defense perspective. So technology in on-prem didn't really change much. So everybody talks about Gen AI, post-quantum encryption, whatever. Nothing really changed. We're already familiar with the architecture of how companies are built, so they might be a little bit different, but the core concepts are still the same. All of us are familiar with Active Directory, lateral movement, privilege escalation, common attacks, bloodhound, attack paths, all of those things. We monitor for specific event IDs. If you take a blue teamer that's doing this for a couple of years and you ask them, wait, what's the event ID for account lockout? Or a Kerberos ticket being extracted, or anything like that, they know all of those numbers from the top of their head. We have common and shared SIEM queries and playbooks, very easy to investigate, to match against. But in cloud, it's very different. When a bucket leaks out, that's a fancy code of unwanted access, and it's very hard to determine, all right, does it actually leaking, or we wanted it to be accessible? What's the architecture when you talk about the cloud footprint? Because different companies use different clouds. Some of them are multi-cloud. Resources might be for the same purpose, but they are built and interconnected in a different way. So it's much harder for the defenders to figure out how our architecture looks like, and should that service communicate with that service on the cloud? Are they related? Is it something on the back end from our providers? And of course, when we want to start an IR, and we know the attacker accessed the SaaS platforms. So in this case, let's take HR, and let's assume they changed the payroll details on a bunch of employees. We don't control that app. We don't host it. We don't have the operating system logs on it. And now we're depending on a third party that might have the logs or not. They might lie about having the logs. And then we can't figure out what really happened. And in the end of the day, when you build a playbook and you build it for a Windows OS or a Linux OS or something within your on-prem, it's very generic. You can use it across the board. But when you build something for AWS, it won't work with GCP. And it also won't work with Azure and won't work with any other provider, especially not with any SaaS platforms. So some of the common figured out security for defense we already have. So for on-prem, we have IOCs, we have hashes, we have signatures. We mentioned that a lot of times so far, but we have also Sigma, Yara, Snort rules. We have things that are already out of the box or require a bit of customization. We can isolate resources and host using our EDR. We can patch vulnerabilities when they come out, usually. But in cloud, we are much more limited. From an IOC perspective, we have IPs and domains, because we don't really have malware running on our own resources. We might have some threat actors. If somebody works for a threat intel company, I'm sorry, don't come at me, that's the truth. But we have IOAs, indicators of activity, as we mentioned. So we know somebody's doing something, but is it a bad thing? Is it a routine, or is it just somebody doing something they shouldn't do? We can't really isolate resources. We can take them down, we can limit access, but it's not really isolation and it's not centralized the way we have it on-prem. And of course, we can't really patch. If a CVE comes in for the infrastructure for AWS or Azure, we're fucked. For security tech stack, so as we mentioned, we have a lot of acronyms again, but all of them sort of make sense because on-prem, they work together, they're interconnected, they're centralized. It's easier to see everything in the same place, or at least most of it in the same place. In cloud, we have a problem. So we have logs. They are never real time. In best case, they are near real time because stuff happens, then your vendor, your cloud provider needs to process them, generate them, and then ship them to your own SIEM. And that takes time. So in some cases, signing logs, which are critical logs in most cases, will take at least 15 minutes before they populate in your environment. So that's super difficult. And the visibility, which is one of before the last piece. We have on-prem, we can enable policy across the board. Easy, we build it once, run it everywhere. Same structure for the logs. So event logs from every operating system, so every Windows operating system will look the same, have the same structure, the same content. Everything's figured out, common types. Whatever we use, we know it's the same everywhere. In cloud, first of all, most of the logs are turned off by default because they cost money. And when you want to enable them, you need to understand what you're enabling, where you're enabling it, and to enable it everywhere. So in AWS, for example, when you enable something, it's only in the region unless you go and do it everywhere. It's not super easy or straightforward, unfortunately, and it's something that's usually being missed. And the content of the logs and the structure is very different. So AWS logs looks very different from Azure logs, that look different from GCP logs, because those are almost non-existent. And SaaS. Does SaaS have logs? Most of them claim they do. Then you go for an IR, and they start saying, yeah, we are working on it. Let us come back in a week or so when we can. In other cases, and in this case, Slack and Microsoft, I'm looking at you, it's blocked based on your license level. So if you're using the basic tiers for licensing in some of those SaaS platforms, you don't have logs available for you in any case. And for the last piece, our responsibilities, accountabilities, all of that structure. So in on-prem, we know who is going to do what. We can yell at each other afterwards that they did a poor job, but we know who should do what. So it's much easier between IT security, cybersecurity, SOC, SecOps, whatever. Usually they also have administrative access, so they can either go within the network or isolate using their own tooling. Every time something new gets spun up on your environment on-prem, it automatically gets your security policies or your SOC package, basically. In cloud, a lot of different teams. Dev team, DevOps, DevSecOps, SecOps, SOC. Nobody really knows who's doing what, where, and when. The SecOps doesn't have administrative access. They don't manage the cloud. That's different teams. And then when they want logs enabled, they ask a different team that's not a security team. Those are clicking a few buttons, and nobody really knows if it was configured correctly. And of course, again, we don't have any control about cloud or SaaS vulnerabilities. So if tomorrow Slack, Monday, Workday, Snowflake has a problem, which is a vulnerability, we can't patch it for them. We have to wait for them to figure it out. So just to wrap it up, another use case I want to go through, and this was what happened with Sisense. So basically, somebody bad managed to compromise one of their GitLab accounts, which got them code access, and there they found a non-human identity. They used that to go into their AWS S3 bucket and steal all of that, which is terabytes of information. And Sisense are serving hundreds, if not thousands, of customers, and within this bucket, they had more access keys for other companies, which make this go round and round and round, and now targeting a lot of other companies. And those companies need to figure out, all right, which credentials we had with Sisense? Can we map those against our environment? Can we see which activities and actions they carried out? Do we know which time frame? Because it came out in April, but we don't know where the actual breach occurred, or we cannot be certain of it. And The only recommendation coming out of this, whether it's CISA or CISA and CISO or whatever, was to rotate your credentials. So it basically was a simple attack. Somebody got access to something, no vulnerabilities, no exploit, no zero-day, no nation-state attackers, nothing fancy. But in the end of the day, somebody got credentials, it's a non-human credential, got terabytes of information with more credentials, and now we need to figure it out. So to wrap up, few, I would say, recommendations from us to you. So next week, work on that visibility we mentioned, because we know we don't have logs and we don't have good visibility. We might have logs available that we do not collect or not enabled, or if they're enabled, we need to make sure they're enabled across the board, all regions, all cloud providers, all SaaS platforms that we already use. We might not see it in their configuration, so it's worth reaching out and asking them, do you have security logs? Because in a lot of cases, they will have sort of application/debug logs, which are less effective for security. And next month, try to see how you can enable security tooling available from your providers. So AWS has GuardDuty, Azure has Security Center and Microsoft Defender for Cloud. GCP has the Google Cloud Security Command Center. Gee, that's long. I don't know if all of them are free, depends on tier, licenses, whatever. Check it. If you have it available, start using it. They generate some of the alerts you want to see as a starting point, and then you can expand on doing, all right, uncover your unknown, which is another cliche I hate, but it's still true. Get a red team, a good red team, to start breaking things. And then when you can see what they broke and you don't know where they went when they got into that specific SaaS platforms, that's a visibility gap you want to address. And then start building your anomaly detection and your behavioral detections. That means that we said we can detect tools. However, if you have a tool, you can start seeing how it's structured, which API it calls, in which way, method, which time frame between each call. It helps with detections. It won't solve security, unfortunately, but it's still something better for your cloud environment. Thank you for having us.
Right. Thank you so much. We don't have time for questions, unfortunately, but Adi and Sherman will be right by the door if you want to catch up with them after this. Next talk starts in about We're about to kick off spear phishing at scale using generative AI. Quickly before I get started, I'd like to thank our sponsors, especially Diamond sponsors Prisma Cloud and Vanta, as well as our gold sponsors, Project Circuit Breaker and SemGrep. It is their support along with other sponsors, donors, and volunteers that make this event possible. As always, please silence cell phones. We are live and streaming to the internet. If you have questions, please raise your hand and I'll bring the mic to you. Please welcome Josh.
Hey folks, thanks for coming. How's my audio back there? Good? Cool, great. All right, welcome to Hello World. Anyone get that joke? Anyone get that reference? Thank you very much. I worked very hard on that. Spear phishing at scale using generative AI. All right, so quick background why we're here. Is there echo or just a little bit of echo? Maybe? All right. Testing. All right, there we go. Thank you, sir. Appreciate it. Okay, so I'm on the internet. You can find me pretty much everywhere at jcamju, or I'm the founder and CEO of a company called Sublime Security. We detect and prevent lots of email attacks. That's why we're here today, to share a little bit about what we've been seeing in the wild, and also share a little bit of experience, some of what we recreated on the offensive side. My background prior to Sublime, spent most of my career in the offensive cyberspace, so it's a little bit of what we're going to be bringing today. All right. So, quick overview of what we're going to be covering. We got a lot on the agenda. We're going to mostly spend most of our time talking about Gen AI use by adversaries and what we've been seeing in the wild, as well as what we were able to recreate relatively quickly to just demonstrate really the barrier of entry to doing this stuff and how low it is. And we'll talk about detection and then defense and depth strategies as well. So before we do, I don't think it's a surprise to anyone that the threat landscape is rapidly shifting. We're seeing this in email in particular, lots of new techniques being employed. Anyone see like QR code phishing recently or heard of it? Callback phishing? I mean, it feels like every day we're seeing new types of attack variants. The question is like, why? What's the motivation behind it? When speaking about financially motivated adversaries, you have different types of adversaries with different objectives. You've got nation states who may be financially motivated, but have other motives as well, like espionage, intel collection. When speaking about financially motivated adversaries, they are seeking high ROI opportunities. There's two inputs into ROI. There's return on investment. Return is the financial reward at the end, and investment is the time, money, resources allocated to achieve that return. So keep this in mind. This is why we'll see, obviously, the adoption of Gen AI by attackers, because it makes them more efficient. So quick terminology overview. Has anyone not heard of Gen AI or LLMs? Yeah, all right, cool. So we won't belabor that point, but just to draw a distinction here, Gen AI is really like the umbrella term that includes image generation, video creation, audio synthesis, code generation, and it also includes LLMs. So LLMs are a subset of Gen AI, and LLMs focus more on text generation, summarization, that kind of thing. For the purpose of the talk, we're just going to use the umbrella term, but just so we're aware of the terminology there and why we're using what. And just a couple words on the landscape here, and we've really got two different kind of even philosophical approaches to the landscape. We've got the closed models and we've got the open source models. Everyone, I'm sure, is very well familiar with OpenAI, maybe not as familiar with the others, Anthropic, Cohere. These are all accessible via API. These are how these closed models make their models available. And we've got the open source models, and you run them locally generally, or you can deploy them elsewhere using tools like Olama. So when talking about what we've recreated, or even attacker usage, you can generally see either one of these depending on privacy preferences or the lack thereof. So we're seeing, I mean, this is probably not news to anyone that this is happening in the wild today. And it's happening pretty much through many different attack vectors, so not just email. We've got the FBI warning around voice and video cloning down at the bottom left there. And we've got Microsoft talking about Forest Blizzard, a Russian threat actor employing LLMs for various purposes. Recon and enhanced scripting generation. So really we are seeing adoption quite literally by adversaries. And bringing it back to the former point around why, right? It makes you more efficient. And it lowers your investment and it increases your return. And we'll talk about very specifically in the email domain what it enables you to achieve beyond just efficiency. Really, we're talking about efficacy of attacks as well. So let's get right into it around the attacks we're seeing in the wild. So a quick note on this, right? It is practically impossible to assess with confidence that something is Gen AI originating. So if anyone tells you with certainty that it is, like unless they were on the adversary's keyboard and observed it happening, it's impossible to say with certainty, right? So we are saying likely, we use likely AI generated with very, very high confidence. And we're making that assessment just for transparency's sake using some of these factors, right? So we're talking to our customers and validating that these are in fact fake threads, fabricated identities, real events that are happening. We're seeing similar variants across multiple customers, but tailored uniquely to certain ones. We look at thousands and millions and very manually, eyes on glass, like thousands of messages, and like we analyze them. So we have a lot of experience. So we've got instinct for what feels and looks like AI generated and what's not. And then we are, throughout the course of this presentation, we will also show the output of some of these AI detector tools. So there's a bunch of these out there. This is a relatively new field, the detection of AI-generated text. So it's very nascent. It's not a reliable thing that you can use to like detect things. There's a lot of FPs, there's a lot of FNs, but it's a thing, so we show the output of some of these throughout this. So here's the first one. This is writing to verify and request invoices and basically start a conversation. And there's a bunch of things happening here. There's an impersonation of an organization's, like a real contact at this organization. What's really notable about this, like invoice fraud is not a new thing, right? That's been happening for a long time, but it's generally riddled with like poor grammar and threat actors that are non-English speaking that clearly just threw some shit into Google Translate and it's like not that really well written. And so this is, what's interesting about this is that it's proper English. There's a structure to the paragraphs here. It reads like relatively well. And so really we're seeing just better formatted, generic. This is like not highly targeted, right? We'll get to the more targeted stuff, but it's interesting because even the low level mass phishing campaigns are stepping up, and they are not your Nigerian prince scams anymore, right? They're well structured. So over on the left here, we also have identified some signals here. We will come back to this towards the end when talking about detection, but I wanted to highlight some of the signals that you can actually use for each one of these. So we'll come back to that. Mentioned these AI generator detector tools. Here's, I think, one called Zero GPT that assesses with high confidence that every single word here was generated with a tool that was generated by AI. It makes these, you can look up how it's making these interpretations, really a variety of factors like randomness, the probability of certain words, the variation of sentence structure, the length of sentences. There's a lot of factors that go into these assessments. But yeah, interesting assessment there. All right, example 2. Who has received or seen a benefits enrollment phishing scam before? Yeah? Okay, a few people. So this is not necessarily a new technique, right? We are seeing old tried and true techniques that are better than before. This is proper English. There's 1, 2, 3, 4. These are all proper, it makes sense. It's well structured. There's no grammatical errors here. And so we are seeing the older, these tried and true techniques around pretext and the techniques that are being employed just stepping up in complexity or in convincing and how convincing they are. The other reason I wanted to highlight this is that there's a PDF attachment on this message that has an embedded QR code. So this is actually a QR code attack. And so you can see the blurred out part there. And so what is happening here almost certainly is auto generation of PDFs and embedding of QR codes as well in attachments. So quite interesting. And here we can see a different AI detector tool predicts 100% of this was AI generated. Okay, on to the most interesting one that we have come across as of late. There's a lot that is redacted here because there are real identities, there are real events, and so for customer privacy reasons, we've had to redact this. But this attack has an entirely fabricated thread with fabricated responses from real identities at the target organization about a real event. And we'll go through each one of these. It's quite interesting. So the first email in the thread is coming from a fake message that's purporting to be from the target organization, an entity at the target that is reaching out to the gala saying that they want to pledge $25,000 to this event. We've got a reply coming back saying that they wanted to express their heartfelt appreciation and send a package for sponsorship. And then we've got a follow-up where in threaded reply 2, these are actually real organization names in the target's industry. So they've done some enrichment here and are saying, hey, X company and Y company are already in, and they filled out the form and whatnot. And then we've got another fake reply purporting to be from the target organization saying where to send invoices to. And then we finally have the last message in the thread, which is what the actual attack is, which is sending the invoice. So we've got someone in finance that receives it, sees that there's been exchanges and everything looks legit, and it is quite in fact not legit. So very, very interesting development here. And you can see that this is, that the AI detector actually does a worse job on this. And ultimately, these things are just they have too many FPs, too many false negatives. So if you are kind of relying on this on a day-to-day, just know that it's a relatively new field that's developing on the detection side. So we did verify with the customer that this was in fact completely fake. Did not exist. The sender's domain, if we pop back over, was actually registered a few days prior to the attack. So it was just registered, newly registered domain. It was designed to impersonate. So quite interesting here. So what's the impact of this ultimately on the email threat landscape? Messages are more tailored, they're more convincing. They're more correct grammatically. They're more diverse when looking at a campaign across multiple organizations. And they have more reach because they are landing in the inboxes more opposed to spam. So just for fun, I wanted to see what it would take to kind of recreate something that was quite convincing. So there's lots and lots of tools. This isn't a talk about OSINT, but there's plenty of talks on gathering information on entities in an automated way. Here's some of those tools. So you can go pull information from identities, from organizations, crawl websites, crawl LinkedIn, all these types of things. There are services that already have all this information, like Full Contact, or even Clearbit provides logos. Give it a domain, it'll give you a logo. So all of these enable you to automate this. And for recency, or for more higher chance of success, if you can include, and this is a personal opinion from just spending most of my career on the offense, if you want to convince someone of something or have a better chance, one technique, use a recent event, use something they said, use something that is highly relevant and timely, not just some generic thing, right? So hey, I saw you at this event. Hey, I saw, something that is much more believable. So we took all this information. This is a bunch of info gathered about me. So name, title, past roles, recent activity from socials. This was one of the key inputs here. So pulling a bunch of my recent LinkedIn posts, a bunch of my recent Twitter posts, and then giving a prompt that we've iterated on. So I'll read some of this. You are a computer scientist who writes very dull, with little excitement, and is extremely terse. Craft an email message. Do not sound salesy at all or make any generic statements. Keep it extremely short and concise, a few sentences at most. It goes on to say, to give some additional direction, mention that you're sharing a document and say how specifically relevant to the observation, how it's specifically relevant to the observations above, and think they'd be useful or relevant. Be casual, double check your work to ensure you are not making up anything that didn't happen. So this is what we get. This was after not much iteration. Hi Josh, I saw your LinkedIn post about the increasing sophistication of phishing attacks. Link post. Your points on adaptive threat detection were insightful. That is relatively what I was talking about. I'm sharing a document on recent phishing methods that relate to your observations. I think you'll find it relevant and useful. And we can embed then our lure in a Word document or a PDF or something like that. Decently, I might click on this. I want to know what you're talking about. Read phishing methods, that makes sense. So really this was an exercise to understand what does it take? And it's the barrier to entry has been lowered significantly. So that's just something to really grok. Okay, really quickly, we'll go through the last few bits here, detection and prevention. So on the detection side, it's not all that different from targeted, tailored attack detection. So even for this guy, right, we're using signals like, hey, you've never spoken to this person before, there's a suspicious Word document, it's a malicious Word document, it's a malicious PDF, there's a suspicious link in the PDF, there's a link that we analyze that auto downloads an ISO. Like, it's not all that different on the detection side, but attackers are just constantly evolving these techniques, right? So, there's thousands of these signals, but the point is that it's on the detection side, it's not very different, even as things get more advanced. And we talked a lot about the offensive applications of generative AI. There's a lot of course, defensive applications from language analysis, intent classification. So this is one thing that we do very heavily around identifying text and understanding its intent. Extracting entities, this is called NER, named entity recognition. Is there a request being made? Is there a sense of urgency? Things like that. And of course, there's so many more around alert prioritization, SOC. This is really just the beginning of a lot of interesting defensive applications. So the last word to wrap up, defense in depth. Really, obviously, like, if you can block it at the email layer, like left of boom, right? As far left as you can go, great, but you should always have a defense in depth mentality. Educate your users, right? It's important to know that phishing attacks can be extremely convincing. It's not just the Microsoft Teams alert or the fake Microsoft Teams alert or things like that. Like, it can be quite convincing. For credential phishing attacks, employ MFA, ideally hardware-based, like YubiKeys. And to prevent BEC, have a multimodal approval for large transactions, multi-layered. All right. I think we've touched on all this. It's still very nascent. It's getting worse. So, thank you.
Thanks. Any questions for Josh? Okay, I'll bring the mic right over.
So with regard to detection, how much are the much more common kind of that grammar, like helping apps like Grammarly, Microsoft Copilot, even just Gmail, how much is that kind of like fuzzing with those detection algorithms that you guys are using to, because we're probably, I would assume, seeing more and more corporate users using that to help themselves, but then obviously with Gen AI then being used to create these phishing messages, how much is that kind of like wreaking havoc with those detection models?
As in for Gmail's detection model, or for like how are they?
So earlier you kind of had like 60%,
Yeah.
Right?
Yeah.
So then obviously you've got more users, like real users, using these Gen AI based apps to help with their grammar and in their email.
Yeah. Oh yeah, like how does that impact detection, basically? Well, that's why I don't think you can use these detectors as like inputs into detection, right? There's too many false positives. Yeah.
One more.
So do you think that, like, I guess the overall mitigations that you would take against phishing, let's say, are like drastically changed by this, or is it just that the phishing's more effective?
The latter.
Okay.
Yeah.
Thanks very much, Josh. Lunch break. Other talks are going on in other tracks. Otherwise, we'll see you back here at 2 p.m. for Hacking Arcades. Thanks.
something spooky I do for you. I'm just trying to give you something. I'm just trying to give you something spooky I do for you. I'm just trying to give you something.
All right, good afternoon, everyone. Welcome back to Ground Truth, BSides Las Vegas 2024. Excited to kick off the afternoon. Hope everyone had a great lunch break with Insert Coin, hacking arcades for fun. Before we get started, a couple quick announcements. I'd like to thank our sponsors, especially Diamond sponsors Prisma Cloud and Vanta, as well as Gold sponsors Dropzone AI and SemGrep. It is their support, along with our other sponsors, donors, and volunteers that make this event possible. Secondly, we are streaming live. Please turn off your cell phones so as not to disturb the internet. And also, if you have any questions, make sure to save some time for questions at the end. Please raise your hand, and I will bring the mic to you. With that, please welcome Ignacio.
Thank you. As I say, if you want to take pictures during the presentation, it's okay for me. And if I looks good, tag me on Twitter because I need to change my Tinder picture, so that's fine. And also, this is my first time speaking here in BsidesLV. And in 2019, I think it's not working there. Okay. Okay. Okay, so 2019 I went to the first conference of outside Argentina, and this one was BSides, so I'm so excited to be here today. I'm Ignacio Navarro, I'm 26, I'm from Córdoba, Argentina. It's like in the middle, a small city, small town. I work in like application security engineer, and I know sometimes I do some ethical hacking when I'm a little bit bored at home. And that's the Twitter, if you have any question later or something like that. And for the picture too. And also, as a fun fact, I love sneakers, and also I made clothes, so that's why I have a lot of that shit. What are we going to see today? I divided talk in 10 different stages. So we want to see a little bit of introduction, how I found this arcade in Brazil, about the company who is owner of the product of the system, some IDORs, work authorization, security in Android, account takeover, race condition, a little bit. They have a web page if you want to book some arcade for parties, birthdays, and that. So a little bit of that web page, some site servers, NFC, and the conclusions. Disclaimer. So maybe some of these techniques and procedures are not completely legal. So I recommend don't do this one at your home. And if you do this one, just take care. And if you found something, please report that stuff immediately. So just don't be an asshole and be defacing websites and that stuff. In Argentina, there was so normal, like 2 months ago, they were defacing websites from public universities or libraries, and why? So we can start right now. Last December, I went to Hackers in Sao Paulo. That's a really, really nice conference, so technical that. But also, they have a lot of parties from Friday to Sunday. So, in one of those parties, I met a girl from Brazil, and then the next day we went to get some beers. And after some beers, we see that there was an arcade place in front of the bar. And then we say, yeah, sure, we can go to play some games. We enter into the place, and there was a small machine like that one, where you can get the card, you can check your money and that. And that was running a really old version of Windows. So I stayed in front of the machine for like 5 minutes looking in that way. And I say, okay, maybe when I come back to Argentina, I'm gonna check what's going on over there. So stage one, that one was the card, just the name of the company and that, not much data. So I Google it, and I run a little directory list with GoBuster, the normal dictionaries. And we didn't get a lot of data. That was just an old version of PHP running Drupal, and they have exposed the info.php. As I say, the version was from 2019. And there's interesting research from Breadmoor, that's the Curie code if you want to read it, it's from 2011. And if you have the file upload on and you get some LFI, you can get some access and execute some commands in that. But in this case, we don't have the LFI, so it doesn't matter. I run a little DNS search with DNSX and subfind there, and subfind, that's the GitHub code, the GitHub cure. And we found the normal domains, but one subdomain called Plus was the web application for check your salary and your history, where did you play, charge some money and that. So I tried to do some injection into that one, but that didn't work because there was a middleware, so you cannot do anything. So you can just check the movements and charge some credit. So I spent like 2 weeks in that stuff, and I don't find anything in that, and say, okay, maybe there is no talk this year. There's no vulnerabilities here. So after 2 weeks, I turned the car, and I see at the bottom, there was a URL from another different company. So I Googled it, and there was an Argentinian one, and I say, hey, we are the worldwide leaders of creating systems for amusement entertainments and blah, blah, blah. Not just arcade, we have bowling, we have skate park, trampoline parks and everything. And that was getting nice. And they have a map with all the clients around the world, public, and there was that more than 2,000 installations in around 70 countries. So definitely I say, okay, yeah, I wanna check what's going on over there. I run a little DNS search too, and I found the API version 2 documentation. But you need if you want to generate the authorization token, you need the API key and the API secret. Just join that string, do a SHA-1 and another SHA-1, I don't know why, and then you have the access token. So if you want to check some API that say, okay, that return a 200 status code, but on the body you can see status access, but the access is false, and the status code is 403, and access denied. But at a certain point you say, okay, we need the API key and the API secret, that didn't work. But what happened if we delete the version 2? In the normal web application, that didn't work. Well, we are from Latin America, so that worked. And you get all the data from that amusement park. In this case, it's in Orlando, Florida, and some in Buenos Aires. And I did another go buster over the API, and I found some endpoint with 200 OK and some data. Most of them were empty, and a lot of them with 400 with a lot of errors. The same one who I show you, syntax error or just access denied. So now we can move to the IDOR and the broken authorization. What is IDOR basically is when you try to access to the object, maybe that's your object and that's okay, but maybe if you want to ask for the 201 and that's not yours, and the application say, yeah, sure, here you go, that's the IDOR basically. So we can check our car. For example, let's say, okay, this one is my car, I have this money in that stuff, I have those tickets, and the image is just the same image I show you. But what happened if we want to ask for another car? So we get access to that one. In this case, okay, this one have $90, those tickets, without any token or something. So just checking. And the same with the customers. And also there was a sequential ID. So you ask for the customer number 1, and you get all the data, the first name, the last name, the phone, the picture, where they live, where they play the car. You have access to those cars with the PIN code. There was a PIN code in the car, but they didn't validate it, so I don't know why they used it. So that was me after I found this shit. I wrote a little Python script to get some cars with some money inside and some tickets just for check if that was working. And there was a demo web page. And there was a 2,000 installation with the same stuff. Yes. I come back to the web page and I start to read the different news about, and they say, okay, we are in Brazil, we are in Prague, we are in Saudi Arabia, we are in Spain, we are in UK, and there's another one most interesting for you, I think. I don't know if you know that place, but there is a roller coaster close to here. I don't want to say the name or anything, so, but I think you know which one is. Number 4, Android application. When I was checking the API, I found an endpoint who say, you have different sources to get the car. One could be the kiosk at the store, the machine who I show you, and the other one is the CRM mobile. So I came back to the application store, and I didn't find it because I was in Argentina, maybe, I don't know. So I went to the normal application, normal places like APK Combo and APK Pure, or Pure. And there was a list with all the applications. So I download one of those. I decompile that one just with APK Tool or Java decompilers, and we get the code because this one was unobfuscated or something, so that was all in plain text. I run a little beautifier just for make it more beauty. Now we can filter. So I run a grep with the API key and the API secrets, the view key and URL, account code, and we get all those data. So we have the application, the key and the secret that for the application number for the API version 2. And I get more application just to check if that was the same stuff. And yes, so the API endpoint was the same, but that changed the API key and the API secret and the account code. That means the endpoint is the same one, but there was a header called account code, and each account code was a company. That was like hexadecimal, like 13 characters, so it could be quite complicated to guess which one is which one. So with that data, we can just point to some company. But also we have Google, and also we have the list of all the customers. So maybe we can search a little bit. But what I'm saying, basically in this case, we send a request to the API, to the main API with the account code, and let's say, okay, this one is an amusement park from Ecuador. And if we search the name of the place, the name of the amusement park, and we send a request to the same one, but without account code, we get the same data. So the API is the same one, and we don't need the account code. What about if we charge some money into that one? We need the token. We have the API key, we have the API secret for generate the token. So we run it, we get the token, and now we can just consume the API. And there was an endpoint where you can see all the different offers that they have, like, okay, you can charge $200 and then you get more 50 for free and that. And also there was an endpoint for generate the sales, just the ID of the offer, the number of the card that you want to charge that money. And that's it. And also, let's say if you want to do the online recharge automatically, we can say that. You can just set the parameter delivered in true, and that's it. So obviously, I didn't run this because I don't want to be in jail. And $200 at least in Argentina is a lot of money. So about the endpoints into the application, there was almost 30 in that one, all of them in plain text, and also they have the parameters, so you can see the body or the query parameters in some cases. And there was an interesting endpoint called update customer that you can change the name. Yeah, there was a post, they have the authorization token, but they didn't validate that one. And the body was the name, the email, and the newsletter. That was just a random boolean to get some spam in your mailbox. But I think the interesting one was the mail, because maybe we can do some stuff if we exploit that thing, because we don't need a token or anything for the user. So, account takeover and race condition. I ask for my user, and let's say, okay, this one is the demo user, and that's your last name, and this one is your email. But now we send the post without any token, just with the account code. And I said, okay, now we want to set the full test, the email, and that's it. And that works, so they don't have any validation. So I record a little bit about that. But I'm so bad at editing videos, so sorry. I mean, I did my best with the application in the MacBook, so. We had account. Demo account takeover. That one is your email, full test. Now we're going to go to webhook, get that email, send the post without any token. And let's say, okay, status success. This one is your new email. We come back to the login. We ask for the reset the password because this is not our account. Send me the password. We receive the email. I should use a speed cam or something here, but as I say, I cannot do that. We reset the password correctly. We set just 1, 2, 3. Now we want to log it in with the new email. sorry. And that's it. We have access for the same account, and the user never receive an email and say, hey, your email was changed. That was you or not. So once we get into the profile, we can get access to all the cars and the history and all the person life, basically. So race condition is when you want to get some different process at the same time. You have some different cases. That one is the QR code for the Pursuer lab, so that's really nice. Basically, you want to use the same process at the same time, but you have different attacks could be so complicated and that. But in this case, I just write well, this one was the offer that say, hey, install the application in your phone and you're gonna get 300 tickets. So I wrote a little Python script, just normal one. I mean, I just send in just a post and that's it, and 100 threads, nothing complicated, nothing so hard. So I run it, and that was 5 hits. And we check the history, and we get all the tickets into our account. And in this case, it was just ticket. But there was another one like, hey, you want to get $200 or $100 and more points. And obviously, I didn't try that one too. About the bookings, I found that stuff on the application, say, okay, online booking, start reservation. I ran a Go Buster over there, and we have a lot of folder exposed. But the most important one was the TMP, the uploads and data. The TMP have some XML logs, store data, and some about the endpoints. You get some APIs over there. You have some values, but it's not so much important on private data. I mean, it is, but not too much. The uploads, I wrote a Python script too to get some interesting file because there was a lot of picture, just the logo and that stuff. There was not so much nice data. And I found 3 different folders called Facturación Argentina. That's mean like invoices Argentina. And when I entered in that one, they had 2 certificates. And I searched a little bit, and in Argentina they use the stuff to say, hey, I'm this company, and I pay and I receive this money from that person. So you can do some funny stuff with that one. But if we have the certificates, we need the invoices over there. So in the data, there was all the invoices from Argentina with a lot of customer data, the address, the phone, how they pay, with which car and that. And there was almost 600, 700 data. And about the booking manager, one of the endpoints was called pose. And they say, search the reservation but last name or reservation code. And you have the stuff, the input, and search. But what happens if you just click search without any data? You get all the reservations. So you get all the customer, you get all the data, who they are, how many person, how they pay. But those one are new. This one, I think this one was from US, from April, March, when I was working the talk. But also, the web page was a little bit weird because they have a lot of errors into the application. You can read some code over there. You have some SQLite injections too. And also there was a fun stuff that you can tip for the waiter, but you can set a negative tip, so it's less money that you have to pay. Site servers. As I say at the beginning, sometimes I'm a little bit bored in my home, and maybe Sunday I open Shoot and I start to find something just to have some fun. And in this case, I found they have the Sendex public, so you can create an account without any validation. I mean, you can just set random email and that's it. And you can get some videos inside. I mean, they have a lot of network maps, like, okay, this one is the infrastructure. You can get some API secrets, some passwords, some API key. So they have a lot of videos with a lot of data. There was a go-karting in here in US too, who using the same stuff. And they have the administration panel public. So you can get all the users from the API, the name, where they live, the ages. That was without any token or firewall, so you can use some DDoS and that's it. And also they have public the panels. I mean, when you're on the karting, you have all the monitors over there, so you can see that stuff too. It's not so funny, but you can see it. About Spain, there was a big different amusement park from the same company, and they have published this stuff. That was like the administration panel for each amusement park. I tried to do some SQLi and that didn't work. But they had exposed the Webpack, so you can read all the code from the application. And they have the API that you can check the different machines, and that give you the status and the public IP for that machine, So you can get some fun from that way too. You have all the roles. There was just 4, but also they have the login part, and they say, hey, you remember the first JSON Whois showed you with all the status access, status file, blah, blah, blah. That was something similar. And they say, okay, if the status code is 200, just give me the token, that's it, go away. But if the status code is 407, do something. But if it is 420, do another stuff. And I say, okay, what is 420? At the beginning, I was thinking, I think this was talking about weed or something like that, but no. That say 420, that give you another screen to say, okay, you can reset the password for the user that you want to do. So this one was a random user, and you can set the new password, and that's it. No validations, no token, anything. So it's like the same type what I showed you at the beginning. About the NFC, I don't want to go in deep with this one because the card, to be honest, was so simple. But there's an interesting article from Chema Alonso from Spain who show you the different vulnerabilities in the NFC and the MyFair Classic system and that. And in my case, I just use the Flipper Zero. So I read it. There was a MyFair Classic. You have some data like the manufacturer, the UID. Each block is the card have 16 blocks with each 16 sector with 4 blocks each one. You have one for the key and that. But in this case, the card was almost empty. The key was by default just FFF. And in the second block, in the first one, you have the info about the company. But in the second one, you have that stuff. And when you decode that one, it's just the number of the card. So there's no validations. So you can just change your card and use the different card that you want to use. And also, I went to Spain like 1 month ago, I think, to Euskal Hack. That's a nice conference too. And after the talk, one guy come to me and say, hey, I went to the amusement park with my kid last week, and I have the card here if you want to read it. And I said, sure, let's go. Was the same, empty card, just a number over there. So basically have the same vulnerabilities that all the cards around the world. But for those attacks, you need a Flipper Zero or some different tools for NFC. So I come back to the application and I start to read the code and I say, okay, if you don't have iOS, and NFC Play is okay, do something. So I continue reading and I say, okay, maybe this one is a little bit interesting. I download the application here from US. I use my dad phone in this case. So we log it into our account. And there was a part in the application that you can get access to all your cars, and also you can emulate those cars with your phone. So you don't need a Flipper Zero or something like that to do that. Just get the application, get a phone with NFC. You have the account takeover stuff too, so you can get all the cars in your phone. And that's it. We are close to finish. I don't know what time is it, but I think we're okay. What we can do basically, we can get the data for all the customers. We can emulate car, access to them, charge some money, or earn multiple times the same prices. And what about here in US? Here is one of the countries with most clients that they have. But what about here in Vegas? But first of all, just try to don't do something stupid after this one. They have some stuff here. They have an amusement park and arcade in somewhere here. They have an arcade in another place, random place, I don't know which one. And they have there's a new place. There is a bar arcade or bar and arcade. That's a new one I saw on Twitter like 1 month ago, and it's somewhere there too. So, but please, I say, don't be an asshole, please. Well, at 2024, we're still having some shitty vulnerabilities and misconfigurations, so you can go to the basis and find interesting and get a little bit of damage in that stuff. And DevSecOps culture could help a lot to the company, because if you are fixing the vulnerabilities at the beginning, you don't need to wait until they are in the production and make all the problems that we always have. Security education and training for all the person, blah, blah, blah. The normal stuff, I mean, not for the security or the developers, just for the whole company. There was an update, because I presented this talk in BSides Colombia in April, and at the moment they never replied to me. But after that stuff, I think they saw the talk or something, and we had a meeting over there in Colombia. I was scared as fuck over there. We had a meeting and say, okay, let's work together, it's fine, okay, I'm doing this one for free, but if you want to pay, it's okay. I just want to report it to you and you need to fix it, it's fine. And that was on April. In May, I write the report and I send the report to them, and they never replied to me. So I did my best at least. So. If you found something, please report it. Don't be having some fun. I mean, you can report it and write a talk and present here in BSides, but don't be defacing website or just make some shit stuff over there. And if someone sends you a report, pay a little bit of attention. You don't need to pay them, but say, hey, thank you for reporting this one to me. We're gonna work on this one, and that's it. And that's almost all, because tomorrow there is the other version of the talk in SkyTalks at 3 p.m. I think, yeah, at 3 p.m. And there will be more data that I can't show you right now with that camera pointing to me. But if you're gonna get more sensitive data, you can go there tomorrow. For the entrance, you need a token that they are doing that stuff over there. And also, you need to give me a beer, I think. That was on the documentation, I don't know why. But that's all, people. Thank you so much.
Thanks. Any questions? Cool. Can you use the desk? Thanks. I saw a hand. Thank you.
Hey, great presentation. I missed the part where you were first exploiting the API. How did you get the API token, or how did you?
No, I mean, I get a token from the Android application.
Okay.
But most of the endpoint didn't have any validation or something like that. They only validate the token for charge money. So that's it.
Time for one more. All right. Thank you so much.
Thank you.
All right. Next talk at 3.
this will get out to for him. I'm just trying to give you something. I'm just trying to give you something. This will get out to for him. I'm just trying to give you something.
All right, good afternoon. We're ready to kick off the 3 p.m. session here in Ground 2 through BSides Las Vegas. Before we do that, I want to make a few quick announcements. First, I'd like to thank our sponsors, especially our diamond sponsors, Prisma Cloud and Vanta, and our gold sponsors, Project Circuit Breaker and SemGrep. It's their support, along with other sponsors, donors, and volunteers that make the event possible. Secondly, phones on silent. It disrupts the stream. Finally, if you have questions, call me over and we can use the mic. Please welcome Amit.
Thank you, everyone. Am I audible? Perfect. All right. So thank you so much for joining. My name is Amit. We will talk about shadow APIs and zombie APIs today. I've been an API exterminator for PayPal for the past year and a half. I've been developing tools, frameworks that validates, expose, and help drive remediation for this issue. And yeah, let's get on to it. So first I'll, of course, define what shadow and zombie APIs are. And I'll show you an example, a few examples, actually. And we'll talk about the preventative SDLC, on how organizations should implement measures to stop shadow APIs from being an issue. And finally, some techniques for major frameworks. And the demo, of course. So in this talk, let's set up some ground rules. Whenever I will say the word API, what I mean by that will be a service from a microservice, or a method and endpoint, or a query for GraphQL, or any resource that is available through API consumers. So, like a form URL that gets some information through a post request or any API request, basically. So everything I will call API. So first of all, shadow APIs. Basically, there are the unidentified, the official undocumented endpoints. So that basically are being exposed through configuration issues or some human error or LLM by mistakes, and they are still externally available through the gateway. Most of the issues are with shadow APIs are that they are not part of the security review process, and often lead to areas of the organization that are not being tested against by the security teams. Zombie APIs, they're similar in their risk that they pose, and but they were originated from actual working APIs, but they were simply forgotten. So, and I've encountered a lot of those kind of zombie APIs where the developers, they know about some issues, but yeah, they're saying, yeah, we're gonna decommission it soon, or we're gonna sunset the application, or yeah, it's inactive but still exposed. Those are still issues that are posing risks to the company. Basically, if you want to categorize this class of issues, they are improper inventory management, and by this definition, they leave some areas of what we call attack surface. So the weakness itself can be categorized as, well, in the definition, it says old API versions or endpoints left running unpatched. That's a risk, right? Outdated documentation makes some sensitive information that might be available through those old APIs. Sometimes they host real data. So let's say that, and we'll see some examples of that. But if we, by mistake, as a developer, if I put out a QA with real data and I forget to delete it after, and it's still being exposed, then those are real risks. Some outdated systems will be a risk because they host some vulnerabilities. And there are many CWEs that can be considered as part of this weakness, but that depends on the business logic or how it's being implemented. So, okay. 1 second. So, anyone's familiar with Resident Evil, the movie and games? Right. I see some heads. Right. So let's dive into this fictional company of Umbrella Corporation. Let's see some of the developers' tasks and the actions that they took to perform the task, and what was the result. You can imagine this corporation as having multiple services that are exposed through several servers, API gateways, right? Going through firewalls and everything. This is pretty standard, right? You don't have to go into the details, just understand that they might have many services that are being exposed, and some of them should not be exposed. So this is Matt. He's a senior developer, right? He was tasked with upgrading the API spec from version 1 to version 2. while he was implementing those in some new features in version 2, he left the old version 1 endpoints active. So he was trying to make sure that the transition was smooth. The old version 1 APIs were never properly decommissioned, leading to shadow APIs. So the version 1 was still accessible with many vulnerabilities in it. That, like I mentioned before, could also happen on subdomains and basically any resource that is still exposed. Okay, so let's go to Alice. She's a full stack engineer. She integrates a third-party debugging tool to troubleshoot some issue with her stack. The tool registered some additional endpoints with the framework API router. So because it needed that to operate. For example, like a Swagger UI or health checks, right? And she forgot about it, and those endpoints were left exposed in production. And that's a major example of shadow API. James here, he was working on exposing some of the endpoints in his API, and he was using a dependency for TypeScript, right, an NPM package, to expose those endpoints. The package itself became outdated. He forgot about it, did not update, did not do an NPM audit or whatever, and those endpoints were left accessible in production. So the even code that we don't see, even code that we took from other developers, might expose those kind of shadow APIs, right? And it's a general idea, a good idea to check with Sneak Advisor when you're installing external dependencies. This is Rain. She's a junior developer. She was tasked with configuring the API router to make sure that the API itself would handle some endpoints. She used a wildcard pattern. So I'm not sure, it's probably too small. I'm sorry about that. But she defined the path with a wildcard, meaning that anything that's inputted into this body parameter would pass through to the service. So some endpoints that might occupy the same path route, basically, would also be exposed. So this is a misconfiguration. Yeah. So I'll rush a bit because I'm a bit out of time here. So Spence here should have took the time and decommissioned some APIs, but he basically forgot because he was rushing to push to deployment. And here's an example by Kaplan of deploying some sort of gateway that bridges between downstream services. And basically what he did was he forgot to put some authentication to limit the access of some downstream services that were inadvertently exposed. So yeah, missing documentation is the major issue. This is what helps with identifying those APIs, and you need to have someone competent enough to make sure that those APIs are properly documented. And I wanted to give an example by an LLM. So the Red Queen is in the movie. She's artificial intelligence, and in this example, she was tasked with working on a feature. She took some time, but the branches she was working on drifted from the branch that other developers were working on, and between those, some APIs were between those in a divergence of those branches. Some APIs were unintendedly exposed. All right. So this is like a shopping list of how adversaries identify and discover APIs in general. So brute force, running a word list and trying everything until it works, less than optimal, but even Blue Team use this to identify some endpoints. You can identify domain names and all the hosts if you have a history of DNS, and that could also lead to some exposure. You can decompile some mobile applications that link to some APIs that also give some information about it, bugs, error messages, logs, and traffic. And some even bug bounty scopes might leak this. Okay, so we see that this is like a major issue, and how we deal with it. So there's a thing called OpenAPI Swagger specification, basically, that is supposed to be a contract between the consumer of the API and what the API exposes and allows. We use this specification to have tools and integration that validate what endpoints we have, and we use this to make security scalable, right? So having a detailed specification of each and every API that we expose reduce the attack surface that we are not aware about. And there's a thing in Swagger, in OpenAPI called Swagger extension, which is just an extra parameter you can add to the specification. And the recommendation is to add the visibility into it and validate against it in the API level and validate against it in the CI/CD, right? So if we know about an API that should be internal, we would never add it to the gateway as being exposed from external sources. And you can use OpenAPI spec with many of the ASPMs and major gateways like Kong and there's a lot, like Microsoft, Google, everyone has their own tools, Amazon, that they ingest OpenAPI spec and basically stop some access to some APIs based on the specifications. The most important thing that I've encountered while dealing with this issue is listed here. Basically, to know what we have, to have the tools, to have the scripts that are running automatically and identifying those in the logs, in external traffic, in all of the tools that we have. OpenTelemetry is a major thing that can be used to identify those. Ownership of the service itself. Who do we call to in the middle of the night to tell him that there's an issue, right? And actually finding this in a centralized place is really important. I wanted to speak a bit about threat modeling. I don't think I have a lot of time. So basically, threat modeling means that we visualize our network, we find the potential risks involved in the architecture, and in this case, what can be exposed and what not, and what can be exposed through various services. Like if a service routes the traffic back to another service, they should be considered within the same level of exposure. And I really suggest if you have any interest in threat modeling to go to this link, Threat Modeling Manifesto. There's a ton of information there. There's also a contest in Vegas this week that are regarding to threat modeling, and yeah. So also OWASP is a great tool for any cheat sheet or information regarding web application security. So in this demo, I will show one technique among many to identify services for Express.js, which is a Node package used to expose web applications. But you can use source code analysis, dependency injection, code injection, framework query, simply asking the framework through its CLI what are the endpoints are, using traffic that you've identified in any of your other tools, and of course brute force URIs always works. Yeah, for Spring Boot, you have many options, like actuators. If you're using Jersey, then you can use the web application descriptor language that gives an XML, and you can use even SAMgrep or other static analysis tools to obtain the annotations that define the APIs, and of course the actuator, which is a debugging tool. There's a few examples on how to achieve this, but let's move on. So yeah, in Flask, for example, you can simply use the command Flask routes, and it will give you all of the routes that are exposed, even the ones that you did not define in the code, like any dependencies. Yeah, I see people taking pictures. Like at the end of the talk, I have a QR with a link to a repository with all of these tutorials, like a workshop. All right, so you'll have everything. And all right, so let's move on to the demo real quick. Okay, so I'll probably skip a bit. So here we run a Node.js application. We use the npm run start. This application I've created 3 years ago. It's a damn vulnerable application that hosts many vulnerabilities and exposes some weaknesses, such as shadow APIs. We run this application. We save the debugging log. You can see. Sorry, you're not seeing the. I'm really sorry. How do I stop this? All right. Okay. Let me start again. So we are running this application. We use npm run start to run the application and save the logs. The logs are saved into a file. Inside the file, it defines every instance of an API registry in the router, that registers a method and a path. And we use this log in combination with the Swagger file to, this is just an example of the Swagger, right? And some of its APIs. And we use this file and a script that I've also provided to parse the logs into a file that basically contains all of the endpoints. So the list you see here is all of the endpoints the application actually exposes, even the ones that the developer did not intend to expose. In this example, we will see a few endpoints. And so you take this, and then you copy it to the folder. This folder contains a Spectral rule, which is a tool used to lint OpenAPI specifications. So it goes through each and every path of the Spectral file, and it will normalize the paths to identify endpoints that basically share body parameters. So let me show you the example here. So the API, if you can see it, the delete user user email. The user email is a variable. It's called a path variable, and basically it can have many names, both on the API specs and both on the route that the API registered. And so we normalize this, and then we compare. We simply run the linter using spectral lint swagger.json, and you can see that it provided us, if you can see to your right there, with the API that are exposed but are not registered properly. So those register form and V1 API docs. And yeah, so as I mentioned, all of these scripts and tools are available Let me just open the last slide. All of these APIs and tools are available through this GitHub repository. And so this is just an example, but in this repository there are many examples for like Django, Flask, and more. So yeah, that's it. Thank you very much for listening.
I have time for about one question while we let everyone scan the QR code. Any questions for Amit? All right, thank you so much.
All right. Thanks, everyone.
All right. Welcome back. Good afternoon. This is the afternoon session for Ground Floor BSides Las Vegas 2024. About to have a talk on Whois and Reconnaissance. So before we get started, I'd like to make a few quick announcements. First, I'd like to thank our sponsors, especially our diamond sponsors, Prisma Cloud and Vanta, and gold sponsors Adobe and Project Circuit Breaker. It's their support as well as other donors, sponsors, volunteers that make this event possible. Also, reminder as always, live streaming gets disrupted by cell phone noises, so please put them on silent if you have not. Please welcome Will.
All right. Thank you, everyone. So the title of the talk is Who is the Boss? Building Your Own Whois Dataset for Reconnaissance. Just real quickly about me, I'm a senior staff security researcher at Sprocket Security. Always want to thank Sprocket for not just the opportunity to come out, but to get to talk about this research project. It was a fairly small research project over the past year, but I think it had value, and I'm sort of interested how other people are approaching this problem. I've worked in offensive security since about 2008. It's my second time speaking at BSides Las Vegas. The last time was 2013, though, so it's been a minute. So onto the content, because I know we have 20 minutes. I think most people in this room have probably registered a domain before. And when you're registering a domain, you're required to provide ownership contact information. So that's going to be first name, last name, address, phone number, fax number, email address. I have a Namecheap screenshot there. And as part of that process, for most modern registrars, you're given the option of applying redaction or privacy to what you put in there. If you decline that and somebody does a Whois lookup on the domain, they'll get back the ownership information, and that's by design. If you do apply the redaction for privacy or the privacy feature, then if somebody does a Whois lookup on the domain, they'll get back redacted for privacy for the fields, and then usually there's a URL that you can fill out and get access to the information depending on the registrar. So it's very common practice to use reverse Whois as part of the reconnaissance process. So for example, if you go to your terminal right now, type in whoisbankofamerica.com, you'll get back the information about Bank of America. So as we said, name, address, phone number, email, that sort of thing. At the bottom, I've sort of boxed out the domain.administrator@bankofamerica.com. So for red teamers, pen testers in the room, I'm sure you've done it, it's very common to use a data broker service to do an API call with, or to the UI as, what other domains have been registered by domain.administrator@bankofamerica.com or whoever we're doing reconnaissance on. And if you do that call through like Whois, you'll get back about 400,000 domains. And typically the process from here is you sort of filter out the domains to see what's valid. In the case of this domain, Whois will also do historical lookups, so these could be domains that have been long gone but were at one point registered by this email address. But really the idea from here is that we can pull out other domains that are owned by the company in scope. So this is, at least some subset of these domains are also owned by that company. So again, for the red teamers, I'm sure you have stories. I mean, I give an example in the past few months. We do what's called continuous pen testing. So it's on an assessment. There's an Apex domain provided by a customer, a single Apex domain. Did reverse Whois, found additional Apex domains. Within one of those, so you do the full reconnaissance pipeline after that. So subdomain brute forcing, port scanning, identifying services. Found a JSON environment file with Azure creds hard-coded by DevOps in this adjacent Apex domain. And that gave us the foothold into the environment through this other Apex domain. So pretty common process. I think many of you have done this before. This is one of my favorite quotes on it by Jason Haddock, so I'm sure many of you guys know him. I saw him walking around the con earlier. And that is, for every new Apex domain we find, we 4x our chance of hacking the target, right? So we have a multiplicative effect by finding a new Apex domain. And sort of in my mind, it's almost like the branch of a tree, right? So we found one Apex domain, now we find another one, and that whole pipeline goes off of subdomain brute forcing, port scanning, all of the things that go along with potentially gaining access just through this additional Apex domain that's found. So although there's some filtering that we need to do, some process that we need to go through, it's so worthwhile that we end up doing it because it increases our chances of potentially getting in. As I mentioned, there are some data brokers, really common data brokers. There are many of them. These are 3 examples. Whois is super popular. really reasonable API costs to do reverse lookups. You can also do regular lookups and bulk lookups. Lots of tools on GitHub to automate that process if that's what you want to do. Security Trails, another really popular one. They're more broadly focused on ASM, but within their documentation, they absolutely have reverse Whois lookups through the API. More expensive, but excellent data. And then Whois XML API as well. I don't use them as much. From what I understand, it's more focused on like OSINT or potentially malware domains, but again, very Whois focused, lots of data. So that sort of lays the foundation, right? We've talked about the importance of reverse Whois, and now we're sort of moving more into the meat of the conversation, which started out with the research project of what if we managed our own Whois data set? So if we were like, all right, we're not necessarily going to use these data brokers for a bit, what does it sort of look like to manage our own Whois data set to aggregate and collect that data? And so the rest of the talk is really lessons learned, building out that Whois recon data set that hopefully you can take with you if you want to try it out. Alerting on newly registered domains, which I would probably argue is the most valuable thing about managing your own Whois data set. And then some disadvantages that we just probably can't overcome, but are worth sort of discussing. Clock for a second. Okay, so we're building out the recon data set for Whois. The first thing we're going to do is source a lot of domains. I start with the Cisco umbrella top 1 million domains. 1 million domains is not a lot of domains, but what I really like about this data set is that it's valid, it's well organized, and it's really good for like unit tests, because as you build it out, you can be pretty confident those domains are solid. Along the way, I tested a lot of different free domain sets, and I have to say this is probably by far the best. It's TB Odan's domains project. His goal is to have the largest set of free domains on the internet. So he has 1.3 billion domains available through GitHub right now. You can bash script it as I did and pull out in the millions of Apex domains. I'd also say what's really nice about this domain set is it's organized by TLD. So if you want to focus on .br, .brazil, or you want to focus on .bank because you're into the banking TLD, it's all organized and you can sort of go from there. The other one, which is really important, and I would say the first two are like historic domains, right? Because they depend on the last time they were updated. But we have this whole kind of problem with our data set where there's like 50,000 to 400,000 domains registered every 24 hours. So there's a lot of domains that are consistently being added and potentially on a continuous scale by one of our customers or whoever you're working with. Whoisds.com, I should say, provides a newly registered domain set. So every 24 hours, they put out a zip file. Inside the zip file is a text with all the domains registered from the previous 24 hours. So it's really helpful if you're charting domains on a daily basis. As part of this project, I wrote an open source tool called Whois Watcher, and we're going to come back to this a couple different times. But in there's a flag --nrd. If you put that on a cron tab, it'll just every day, for say once a day, it'll download all the domains from the previous day. So you don't even need to go to the website, it'll just automatically do it for you. Okay, so we're trying to build our data set. We have a large set of source domains. Now we need to begin to do Whois lookups on them. Unfortunately, we can't just do that from like a residential IP or a home IP. There's IP rate limiting by certain registrars. There's certain reasons why you just wouldn't want to run it from home, essentially. I'll talk about 3 different ways to do lookups. The first one is IPv6 proxying. So actually, I didn't know about this technique till about a year ago. But when you get a VPS and you enable IPv6 on it, they don't just give you like one single IPv6. It's not like IPv4. They give you a range of IPv6 addresses or a net block. So like DigitalOcean, I think, is like maybe 15. But if you go with a $5 linode, they'll give you a /64, which according to ChatGPT is sextillion million domains. I just wrote thousands of millions because I wasn't really sure. It's a massive number of source IPv6 addresses that your single system can take on. So Black Lantern Security has a tool called Trevor Proxy, which sets up a local SOCKS proxy to rotate the source IPv6. So if you have that set up, then any request sent through that local SOCKS proxy will modify your source IPv6 and essentially rotate it as part of the process. Whois Watcher supports SOCKS proxying, so you can use it with this. It's an excellent tool, works very well. The one downside is not all registrars support IPv6. So what you're going to run into is certain subset of domains just can't be looked up with IPv6. You have to fall back to IPv4 or another technique. All right, second one. Whois lookups. So that's IPv6 proxying. I've clocked it at about 100,000 to 200,000 domains per 24 hours. Pretty good, but not the best. Next would be RDAP. So there's been, like many protocols, there's a history to it. Whois goes back to the 1970s in a RapNet. Elizabeth Feinler's team, and she was like pivotal in that she also helped develop DNS. They helped develop Whois as part of RapNet. Originally, it was sort of like a white pages. And then in 2005, it was updated to what we sort of look at as the current Whois protocol. So that's on port 43. It's unencrypted. It's human readable, not machine readable. And around 2017, started introducing RDAP, which is a REST-based API for Whois lookups. It will also return JSON. This sounds amazing, right? Like, oh wow, now we can just do HTTP, REST-based lookups on domains and get JSON back. Unfortunately, not all registrars support RDAP, and here's like the list of those that do and don't. And again, like IPv6, you end up having to fall back to a different technique to do mass lookups. Probably the most effective way I've seen to do it is through serverless cloud. So again, I mentioned Whois Watcher. It's a small Go tool. You can easily deploy it into AWS Lambda. So you can use like the AWS CDK, which makes it really easy to create a function and a function URL. That was my preferred method for a long time. And then last month, I don't know if anybody saw the tool Lemma. Has anybody heard of this tool? Really interesting. It allows you to deploy like offensive tools into Lambda function URLs very, very easily and helps you use them at scale. So it's an excellent tool. Def Param is the author, if you want to look it up. And in there's a script called tools install tools.sh. You can add Whois Watcher into it, and then it'll automatically deploy into a function URL. So here's really the meat of this point. I probably could have started with this full bullet point, but if you're doing it through serverless cloud, 400 concurrent invocations, which isn't a lot. Like most people's accounts allow for 1,000 concurrent invocations per region. But with 400 concurrent invocations, you'll complete 1 million to 1.5 million complete queries per 24 hours. So it's more than enough to do newly registered domains. Whois Watcher will also respect IP limitations. It has a built-in backoff. So if it detects that the registrar is like, hey, you've made too many requests, it'll back off of it and stop the request. I'd also highly recommend, someone on the team pointed this out, you can use AWS EventBridge. So if you set AWS EventBridge to run every minute and do like a modify of your Lambda function, so like almost doing nothing to it, but just modify it, then the AWS infrastructure will redeploy it, and so you receive a new source IP. So every minute you have a new source IP by doing a simple just modification through EventBridge. This is the command at the bottom here. So like cat domains, this could be the past 24 hours domains, piping into Lemma with 400 invocations, calling Whois Watcher, and then saving the results. So pretty painless way to do these mass lookups that need to be done. All right, so we have a set of source domains. We have a way to look them up. Now we need sort of an application on top of that, unless you just want to take the domains and analyze them. One of the best applications that I found is alerting on newly registered domains. So if you're doing like red teaming, continuous pen testing, bug bounty hunting, then as these domains come out every 24 hours, you may want to be notified that a domain created was by a customer that you're following along with. So if we go back to that Bank of America example, and we have a registrant email of domain.administrator Bank of America, we can create a YAML file, and I called it watch list here. It has a key of email. If the email contains Bank of America, then I want to be alerted. So we're taking that Lemma function, or however you've saved all the domains. We set a watch list so we get notified if any of those domains are of interest, and then immediately we get updated so we know, hey, something of interest just got registered within the past 24 hours. Let's kick off the reconnaissance process from there. Another big advantage, I would say, so with the data brokers, your reverse lookups are usually scoped down to email, company name, and actually organization. So it's email and organization, and then domain name. But when we run the data, when we own the pipeline, we can do reverse lookups on multiple points at once. So on the left here, we have Tesla.com. They've redacted everything, but they have a registrant organization of DNS. And one thing I think you've probably seen if you're into Reconnaissance is companies tend to use the same registrar for all of their domains. And it kind of makes sense, right? You wouldn't want to register half your domains with Route 53 with AWS and half with Namecheap or something. So they tend to use the same registrar. So we can use a combination watch list. So we have our combo of domain contains Tesla and register contains their registrar. And then we'll get alerted on other domains that are their potentials. They're going to require a little bit of work, but they fit into that 1% grouping that takes us over the line to maybe find a really impactful finding. So these were 2 example domains like I ran through like a large data set. I'm not sure if Tesla actually owns TeslaUnionFree.com, but it does match up with the name along with the registrar. And obviously you can combo on other points too. You could do zip code, address, right? You can do different ones. I can think of an assessment from the past 6 months where I identified a domain. It had a very specific name to one of our customers, and then it had a registrar of AWS. And that led to it wasn't a big finding, but it was like a WordPress site that had just been sort of stood up and forgotten about a little bit. So the technique definitely works. It has a bit of a high noise value, as you might guess, but it's absolutely effective. And especially when you have the pipeline in place, I mean, it's easy. Big disadvantages I would definitely call out. Number one is the data brokers have historic Whois records going back well over 10 years. I think I saw 2007 for one of them. I wasn't sure which one it was. And that's a really big advantage because if we think of like a company, like let's say we're doing Tesla and they've redacted, there might be a point in the past where they didn't redact that information, where that email was available, and then they can cross-reference on other historic emails and find other domains. So data brokers definitely have the advantage there. On the upside, it may be a limited number of API keys that we're burning in order to make calls on historic data. But overall, they do have excellent data. Second disadvantage I would call out is buy versus build, which comes into play with all of this sort of stuff. The data brokers will sell most of this data wholesale. So if you were like, I want every historic record for 550 million domains, you can buy that from some of the brokers that I talked about. It's quite expensive, but you can buy it. You can also get it as a service, obviously APIs or the UIs. Whois DS in particular, if you wanted to do newly registered domains, you could pay to have their service of every single day instead of just the domains. I would like all of the results from Whois. But again, you'd find the pricing on the website. It's not necessarily cheap. Second, this one maybe is a wash, but you do need to manage and curate your own data. So as you're building this out, you have to make sure, have I been IP rate limited on certain domains? Do I need to recheck them? So it's really important to sort of manage your data. But again, you also get a really good glimpse into how the data looks. I mean, I have seen from the data brokers cases where they are IP restricted in some cases, and we'll have better data in our own data set. So there is definitely high value. In terms of the size of the data, it can easily fit into ClickHouse, PostgreSQL. It's not a ton. One thing I'd also call out about Whois Watcher is rather than being human readable, it'll give you JSON. So you can get all of your domains in JSON and then stick it in ClickHouse, and then immediately the columns are made out for you, and you can analyze the data that way if you want. So I guess in closing, couple takeaway resources. This isn't online yet. I was a little sketched out by the Wi-Fi, so I didn't post it yet. So it's a private repo, but it'll be up tonight. And it's basically, as this research has gone on, just taking notes about blog posts and interesting things I've seen from Whois. A lot of really interesting work that's been done over time. So it's cool to see that, and I put that in there. Certainly, if you're into internet scale scanning, I would love to talk to you. I find this stuff super fascinating, and coordinating it, scaling it, thinking about it. So please come talk to me. I mean, that's part of the B-Sides mantra. And then that's all I had. So I don't know if there's any questions or questions from it. Yeah.
So are you picking on Bank of America because they're on the other side of the wall?
Are they a sponsor? Oh, my bad. No, I did not do that. I have noticed a little bit the banking domains. I don't know if they have a legal requirement to expose Whois data, but that could be part of it. But yes, I absolutely was picking on them. No.
For the collection of list of domains, ICANN has a centralized zone data service, which allows you to sign up and just get a zone file for every TLD, and it's updated daily. Did you try using that as a source for domains?
So here's where it got a little bit off the camera, but is that a researcher required?
It doesn't need to be research. They say it's available for research, education, security, law enforcement.
Okay.
Anybody can sign up. I have an account for it, and they just provide you with an FTP, and you can download the zone files for every TLD daily.
And so it's the newly registered domains? Sorry, the newly registered domains?
No, it's every domain registered under the TLD.
That's what I thought.
Yeah, it'll give you every domain registered under the TLD along with the name server, I believe.
Okay. Yeah, because I looked into it a little bit, and I wasn't sure about the terms of service. That's the only reason. That was my hesitation. But did anybody need me to repeat that? If you want to just repeat that really quick, because it's valuable.
What
where to sign up and get?
Oh yeah, you can go to ICANN. It's called the Centralized Zone Data Service, but you can sign up there. You have to provide information, and you're right. There is a terms of service. I think they just say you can't use that information for commercial purposes, which is kind of fuzzy. So you can, as long as you're not selling it, I think it's probably fine. But I'm not a lawyer, so.
No lawyer.
Yeah.
Appreciate it. Thank you.
Another non-question in a similar vein. There's also OpenIntel, which uses the certificate transparency P certificates in a log to see what certificates were issued. And they provide data sets of domains that are in ccTLDs, so domains that don't have the ICANN contract which forces them to publish the data. And I think they also have a Kafka stream of recently registered domains. So they may also be very interesting to explore. And for everybody who's into this topic, it may be a very interesting resource.
Cool. What was the name of the resource again? I'm sorry.
OpenIntel.
Oh, OpenIntel. Okay, yeah, absolutely. Yeah, the transparency log stuff can get super interesting as well.
So what percentage do you think of your DNS lookups and stuff are you getting missed because of, per se, like a vendor uses a third-party hosting provider that then gets all that stuff registered underneath them, but it's actually managed by that main party? So how much do you feel like you are missing out by misdirection of this project was stood up by a third-party vendor and all the DNS records are pointing towards that third-party vendor instead of the main vendor that contracted that?
So we're talking about like a Squarespace or an example of, that's a really good point. What I like about the data is we can sort of slice and dice it a little bit more. So the first thing that would come to mind is like 2 data points probably. So we're taking Squarespace plus some other piece of information, maybe we can derive a little more, but percentage-wise, I'm not sure about how much we're missing there.
Thanks. We're on break for about an hour, and we'll see you back here after that. Thanks, Will.
Thank you.
for him. I'm just trying to give you something. this will get, I'll do it for him. I'm just trying to give you something.
Good evening, everyone. Hello. This is BSides 2024. The ground floor sessions are afternoon on Tuesday. Before we get started, I would like to thank our sponsors, especially our diamond sponsors, Prisma Cloud and Vanta, and gold sponsors, Adobe and Project Circuit Breaker. It's their support as well as other donors, sponsors, and volunteers that make this event possible. Secondly, we are streaming live. The streams don't like loud phones. So if your phone is not on silent, please take care of that now. With that, please welcome Angel.
Okay, so I do have a PDF you can download here of the slides minus the videos if you would like to go and follow along or have notes and links for later. So this is just something you can get. I'll give you about 15 seconds, and then we'll go ahead and just start on with the slides. But yeah, thank you everybody for coming to Tactics of the Trash Panda, the real TTP acronym, the only TTP acronym. All other acronyms are garbage compared to this one. I still see phones out, so I'm going to wait a little bit. Cool. Let's get started. So just a quick who am I? I am an InfoSec doer. I'm a senior consultant at Dark Wolf Solutions. I'm a 3D printer enthusiast. I've been hacking and doing crazy things, but getting paid for it for the past 6 years. I've been trained in multiple disciplines such as NetPen, AppSec, physical, vulnerability research. I'm a proud member of DC316, occasionally drop by AHA and SecKC. I do have a disclaimer here, so the following presentation will deal with security and adjacent topics. Consequentially, some of the content may be of adult nature. This content is handled in a professional manner by me, and I hope you can handle it with respect as an audience. So if you do have any qualms against this, please feel free to leave the room now. If not, whatever. Additionally, content is provided for educational use only. I take no responsibility for any actions taken by the audience as a result of this. Let's behave ourselves and have a little fun. So let's talk about like modern physical entry and red teaming. You have this problem of tradecraft problems. As you get into specialized tooling markets, you start having the need to fill those markets and needing to improve on that. And that either costs money or development or reduces the ambiguity you can use on site with certain pretexts. These tools become less of tools you can mend to your pretext and more just red team tools, right? Some other problems is your geographic location where you're performing these tests may restrict you from utilizing certain tools. We know Canada has some stuff going on proposed for a bunch of SDR stuff. Lockpicks are illegal in certain countries, and per state there are different lockpicking laws. I'm not an expert on the lockpicking laws. You can talk to the people at the Lockpicking Village for that. But let's get down to some proposed solutions. You have Batman over here, which looks weird in some movies. He has like money or something, and he just breaks into places that he could just buy easily, right? But on the other hand, you have a raccoon. They look awesome, they eat trash, and they break into anywhere without spending a dime. So how do we mimic this behavior? How do we become more resourceful? Today I'm going to be telling you about how to do this, and I'm going to be walking through how to present yourself and advice for packing, my own kit, commercial tradecraft and tooling primer, attempting to replicate these with our own variants and some video demos, and then I can show you how to practice on your own in a kind of legal way. So just a quick thing about physical evaluations. They're a great way to show the internal network isn't too hard to reach. There's a lot of prep work before even scoping the place out in person, and all your legality and paperwork is a pain. Normally you go to a consultancy that has this figured out if you're trying to get into the field and do this testing instead of going freelance. And you can't always use repeat pretext for scenarios. There's always something unique about a test. So preparation mainly entails lots of preparation, of objectives, your connections, your out of office, your trash schedules, your tech stacks, your fire code, your disability measures applied to the building and whatnot, your surveillance schedules, your antics behavior, contingency planning, having good luck, and a lot of reading. So some of this reading might be your normal fire code. So NFP 80 is like an RFC but for doors and buildings kind of. There's also the ADA compliance standards, and these are for, in the US, they're kind of like RFCs, but for doors and buildings. And a lot of modern tooling that is considered red team tooling is based on the foundations of these documents. So let's talk about getting into pretext packing. An improv class goes a long way before you go out and register for some advanced red team training or something like that. You might just try your local theater and just get the basics down in one discipline first. I have used multiple pretexts. Some of the more common ones are here. These are by no means comprehensive. I've used the authoritative pretext of, oh, I work for a help desk, or I'm an IT person, or I'm some C-level that hates people. I don't know. Or you can have mutual bonding, lighting somebody's cigarette. You can hold the door open or be courteous and kind, right? Or you can be a meek inquisitor. If you're trying to gain information, you can go around and ask and say, oh, I'm new here and whatnot, and weave your shenanigans through that way. But play to your strengths, right? These pretexts, it's never, oh, I was born this way, so I have infinite pretext or something like this. It's always whatever you find is good about yourself, and you can strengthen that and use that to your advantage in pretext. Game is game. If you get into the building, like, that's it, right? Like, cool. So a little more about packing. Prepare for multiple pretexts to be used. Don't just have like one outfit, right? Have the ability to maybe even swap on site once you're outside of the hotel room and on the client site, being able to change. There's lots of treasure troves of information online from employees and charity events and whatnot that you can scrape that information from. Don't impersonate in ways that will make you catch a case. Please do be legal with this. Talk to your lawyers if you have questions on this. I'm not a lawyer. Have clothing for your archetypes and covers, right? If you have, say, a construction worker vest, don't bring that shit in clean. You're gonna walk into a place with a nice shiny hard hat and a clean construction worker vest and, oh wow, yeah, I've been here for 3 years working, or hard day's work, and no, get out of here. Like, how I phrase these types of pretexts and planning, I do say an improv class goes a long way, but there's kind of a framework I have where I use props to perform my skit with punchlines as the anchors. So for instance, you can have a clipboard with an RFID reader inside, and you can have a coffee and a handkerchief, and these can be your props, right? And you can say, oh, I want to get a clone of somebody's badge, so I have to get really close to them, right? And let's say some scenario plays out where you're outside the building and, oh gosh, hey, could you hold this for me really quick? I got this coffee all over my shoes, I spilled it all, I'm just cleaning up. Here, hold this clipboard with the RFID reader next to your chest, right? Things of that nature, and always, work with the flexibilities you have. Normally, you don't have to worry about your hotel rooms being searched, but obviously with some recent happenings at resorts in the area, that might be, I need to update that slide. Talking about practicality packing, bring just enough tooling. So different goals will have different loadouts. You want to have raw material for lots of use cases and maximum flexibility, such as wires, strings, and pins. You want to plan for failure, so if you're caught with a certain tool out, how do you talk yourself out of that situation, right? We don't want to have to just pull out our letter of authorization immediately and that's it, that's the test, right? We want to kind of try to fall gracefully as we do this. Practice quick deployment. So as you work with your tools and specialized equipment, you want to practice pulling that out, putting it away very quickly so you can increase your speedrun strat for this, to say. And then also check what's legal and allowed on your person in case of X event. For instance, in the state of Kansas, you may be required to give fingerprints if a cop catches you and you have pics on your person and you're doing some type of burglar activities, right? So here's my kit and the approximate usage for it. So you can see here there are a lot of familiar tools, and I'll start moving over here. My most used one by far has to be these plastic shims and this like local supermarket shopper's card. But I have gear ties, flashlights, some bump keys, a little lever, like a wedge thing, some shims for loading, our punch bar, our traveler hook, some bobby pins, my under the door tool, and we'll get to the mods and some of those here in a second, and extra Kevlar rope, and yeah, just all the goodies there that aren't electronic. And here's some other stuff. So there's my modded under the door tool based on Debian Alums and Not So Civil Engineers modifications that they committed to their under the door tools using Kevlar rope. There's also the Humble Firefighters Mini J tool, which is great. I think it's an awesome replacement for a double door tool that you can find online. And this is just made out of some cheap titanium rods you can get off of Amazon. So what I don't show here is, of course, all the cables for the gadgets and gizmos, but here's all your electronic stuff. I've lost numerous Leatherman multi-tools just because I forgot them in my carry-on, and TSA had to confiscate them. RIP, right? But yeah, for the rest of this talk, we'll cover the physical entry, implants and devices, and what your wireless evaluations. So talking about your under-the-door tool options, Not So Civil Engineer has amazing guides, comprehensive guides on your under-the-door tool modifications you can make for different outlooks and different scenarios. So you have your standard under-the-door tool from Sparrows, and other vendors will do this. You can buy that for about $40, and that's 1/4 inch to 3/8 inch high carbon steel, and it's foldable. It lasts pretty long as you take care of it. If you're in a pinch, you can buy zinc rods from Menards. And these rods do not retain the shape well, so prepare to use these for like maybe 1 or 2 uses and then throw them out. Other metals, try it and share. Titanium could be a proposed solution, but it's really expensive in that size, so I wouldn't recommend it as a budget option. So getting into your budget and low profile options, you do have some Not So Civil Engineer recommendations of the copper tubing at 1/4 inch with framing wire. And you can make 3 of these for about $30 in my local market in the Midwest. These you cannot easily substitute Kevlar cord for, as you could the normal under the door tool, and we'll see why here in a second. Your takedown under the door tools, which is the ones that bolt together, they add a little bit more thickness to it, and they can be harder to fit under certain scenarios. So I don't really go with that. You can compensate by carrying an air wedge with you and rely on that more, but it's not an option I really use in the field. So looking at the mods, here's a close-up. So I've dug this groove, similar to what's recommended off YouTube, right, with a Dremel, and I just put my Kevlar cord here, and I'm able to use this on crash bars and whatnot, because this hooks into the door, and I'm able to use the cord to push that for the crash bars and actuate that, right? And I have some tape up here so that it's increased friction. Now, this is the one you can't substitute Kevlar cord for. So the reason you can't do this is because this is dog catcher design, and this is meant to be for doors with little levers, so you can slide this under the door, and this is where the door is sitting, and you can actuate the handle by grabbing it, kind of like animal control does for dogs, right? And you just pull this little cable right here. And Kevlar doesn't really work for that. Talking about shims, so some people buy the super mica shims from Red Team Tools and other vendors. These are kind of expensive. You can buy them in bulk. They're just called Mylar stencil sheets, and we'll get to the measurements that I recommend here in a second. But yeah, the bulk is much better value, and you can cut them however you want. You get much longer material, so you can be more flexible with it. Dylan's card or supermarket card, this one just happens to be a good combination of thinness and rigidity. And it's free, it saves you money in the long term, and like what accusations are gonna follow you if you get found with a Dylan's card, right? Like, oh, I wanna save money on gas, oh no, like kill me, right? You can use laminated paper. I've had buddies who have used this, but it does take work, and this probably means that you've lost your other tooling and you're really in a pinch. So yeah, just explore your options there. So for shims, I recommend 14 to 16 mil thickness for the best results. Your 10 mil thickness is tolerable, but cutting these, you're gonna have different notches for different types of locks. Should you ever run into, say, this lock, you're going to cut a notch like this and be able to close the door on it so that you push on one of these arms, and then you'll be able to actuate it open as you're closing that door back, assuming you've got the other locks handled on the door. This is the normal hook that you do for your normal bezel out style doors, so you can lloyd those latches properly, and you can just open that door like it's nothing. I did run into a couple scenarios where doors had improper latch mechanisms and deadlock mechanisms that they just added one of these after we exploited it, and I was like, wow, does that help? Because I was actually curious. I wasn't being sarcastic at the time. It does not help. All you have to do is just have a long piece of material that will go through the top or the bottom of this, and you can just fold that up and put it in your wallet. So that's hence buy the Mylar stencil sheets so you can fold those up and deploy these long mechanisms out. Oop. Got a little video demo for lloyding here. And this is all it is. Lloyding's been talked about heavily on the internet. I'm not going to reiterate it to you, but this is basically the gist of it. that deadlock plunger isn't properly actuated, so we're able to just push that in and open the door, no problem. So talking about strings and cordage, we noticed in the under the door tools, I had some steel examples and Kevlar examples. The steel cable is coated and shielded. You have to inspect this prior to every use, otherwise you will really mess up your client's doors. And that's not a very good look when they're paying you to do this work. We want to be respectful with our entry. Your rigidity increases the space taken by storing it and folding it up, so it's harder to pack at times. And it's difficult to cut without your beefier tools, depending on the cable thickness you get. Your Kevlar rope is great. It's more forgiving and it's easier to cut. The only problem is not like nylon rope with burning it. To seal the end off, you have to use some type of resin or epoxy so it doesn't fray on you. But this is great. You can get 1.1 diameter thickness and it holds about 200 pounds of force on that rope, so very tough stuff. Seamstress tape has been used before on the internet a lot. You can use this as an under the door tool, but it goes over the door technically and it actuates the lever from the top side. And you just slip that around. Same with 35mm film rolls that we've seen before on the internet. And that stuff I didn't demo because it's been done so many times. It's not like an original idea. I mean, none of this really is original ideas, all right? I recommend gear ties as well. A buddy of mine recommended gear ties to hold your gear and fold your under the door tools and hold things together, and they're amazing. And I have about like 2 on me almost all the time. So, talking about wire, I bring electrical wire, DuPont connectors, just for some programming over serial for certain devices and implants, and then I have alligator crimps just in case you do need it to tap into things. Physical tooling, I have 2mm thick wire. Pliable and capable of holding its own weight, so you can get this from barbed wire or real estate signs, estate sale signs, and fencing wire. This won't harden very well, so if you want to use this for more rigid purposes, it's not going to go well. Talking about picks, so your lock picks are not always accessible in lockpick form, right? They come in many shapes and sizes, and you want spring steel and high quality ones normally. But we don't have that blessing here in this scenario. We're a raccoon. So we are using bobby pins and windshield wipers, which has been done all over the internet online. So here's how I do it with bobby pins. So you get your normal bobby pins, you cut the ends off, right, the little bulbs. I recommend filing down the edges because you will cut yourself otherwise. I've done it multiple times. And then you can use it as a lockpick, right? Otherwise, if you're going to go to O'Reilly's after a rainy day, you can pick up all of these beautiful windshield wiper internals and turn these into your lockpicks. And all you have to do with these are steel or some type of steel metal. So you can just heat these, bend them, quench them in water, or use motor oil, and they should be good to go. And that's a tension wrench. And this one I just filed with a Dremel. As you can see, it's very crude, but they work, right? You can use brawl wire as well. This stuff's pretty good. If this is something that you can carry on your person or works with your pretext, that's awesome. Use it. It's good stuff. Just make sure to cut the ends off and pry all the weird silicone stuff, rubbings from it. Talking about keys. So a one-time investment in known keys or cabinet keys, you can be the key duplicator for your entire community. You can buy one of these key duplicating machines, buy one of those rings off of eBay that's $70, and just start printing out keys that are the same as these. These are very easy to pick up and use. You can learn it in about 5 minutes, right? And Keychain of the Oak City Locksport, they have their pre-made keys that you can find online, right? So here's an example, CH751s. And then bump keys. Bump keys are, this is a known thing, are used to have bump attacks on locks and be able to break easy locks open, right? Just by actuating as many pins as we can at the same time and trying to get that. These bump keys normally are paired with these goat banding kits for faster reverberations towards the back. And yeah, these are very cheap and they're used for goat banding, and you can use them for these bump keys. It's amazing. So here's an example of that. And we'll get to kind of the science of the bump hammers here in a sec. So as you can see here, here's the normal key. Nobody steal that bidding, that's my house key. And then we have our bump key with our heavily used goat banding kit. And by heavily used, I mean on the bump key, not goats. I'm not going to reuse it that way. That's not sanitary. So as you can see here, we're just fitting it, inspecting it before use because these can break very easily. And we're just going to take a solid hammer object or something and just bump the back of it while we're holding slight tension on that in the direction the key is supposed to go. So as you can see, it's not open there. We'll use a screwdriver. I'm just going to tap it a few times. And it opens. And there, it turns, right? Oh, bump key, crazy stuff, right? It's not too crazy, right? Oh. slideshow, come back. Alternatively, there's an energy transfer that you can mess with. If you have materials that are stiffer, they will make more sound on the bump hammer, as opposed to materials that are more gelatinous. So as you can see here, I have an ASA printed phallic device, and this is something that you can use to bump the key very easily and even faster than the screwdriver, really. It was like midnight when I printed this, and I was hot off the press, and I was like, I hope this works, just go, come on. And yeah, it just opens right up. So that's one example. If you go on the other end of the spectrum with something more gelatinous, more like a silicone, what you'll get is you'll get worse energy transfer, so less reliability, but you'll get a much more stealthy approach that won't make as much noise. For size recommendations, if you're going the silicone route, I do recommend about 6 to 7 inches. That was a 9-1, that was way too much, it's unreliable. But yeah, like the sweet spot about 6 to 8, something like that. So. Now, the question is like, why would you do this? Like, what's the point of this besides it's funny, right? Like, it is funny. Having a flamboyant device when you're doing these types of things can create a guise. Normally, when you're talking to guards or looking at how they're trained to solve escalations in terms of encounters, but they're not trained to, come around a building and they see a person knocking on the door. Normally, if you turn around with a bump hammer that looks like this, you might eat lead because this is very threatening in the middle of the night. And oh, that's a bump hammer. There's no way you're going to talk yourself out of that. But if you're coming around and you're bumping a door open, security guard shines a light on you, and you're like, I'm sorry. My boyfriend and I have 7 years. He works here, and we broke up, and I'm just going through it. They're not going to know how to respond sometimes. It's something that allows you're already caught, you're already to the point of almost failing. You can gracefully fall and have a non-0% chance of getting away with it. In the story, this scenario is based off of the guard simply walked away and just left. They didn't report any of this. They didn't call extra authorities, none of that. They just left. That's just how it went down because some people aren't trained to handle that. So again, people have used vibrators and pumpkin carvers for lockpicking guns. I think this is like too much of a power requirement, and it's too noisy, right? For the meme, it's cool, right? But usefulness, it's not as useful, in my opinion. But yeah, the more flamboyant, the better. So let's talk about keys and replication of keys. This slide I actually made the day the replicant was dropped on Covert Insurance website. And what had happened was they were like, oh, $90 for this kit. And we look at what the kit is, and cool, it's all put together and whatnot. I can order it very quickly, but 20 ounces molten clay, all this metal ingots, okay, a crack spoon, and then some other stuff, right? However, this wonderful individual on the internet made a 3D printed model of a similar device. So all you have to do is have a buddy with a printer or print something on your own and use this device, and you're able to replicate keys. And let's look into the process of getting that. I recommend Sculpey 3 polymer clay. Other Sculpeys have kind of been an issue, but essentially you just want to pack this with the clay and make sure it's rolled flat, right? And then what you want to do is you want to put some type of baking powder on this, some type of thing to release that. Releasing agent is what it's called. Some people use like baby powder. I use baking powder. This is what I had on hand. And then you put your key. Let's say you obtain the key and you need to mold it now. So okay, when I got the key, give me about like 10 seconds. Okay, put it in, take it out, and you carve this little hole so air can escape when you're casting this key. And then once you've done that, the process looks kind of like this. A blank YouTube video. I see people doing this all the time. It's like a common thing. So yeah, they're big into security. Everybody's big into security. But yeah, as you can see here, I'm using very primitive tools, just a small Bic lighter from a gas station, a spoon, and then I've got the, this was actually not Woods metal, it was Cerosafe, which is slightly different, but still primarily, or like a third lead. So be careful with these. You should use gloves and like properly ventilate and all that. I say as my hands are bare in this. But as you can see there, we have the cast, and the cast is held together by none other than a gear tie, yeah. And we get this melted, and once it's mostly in liquid form, we just go ahead and pour that, and it fills the cast. And actually, this take of the video, I actually messed it up, so it didn't go in very much, and it broke. But after numerous tries, we got it. So I essentially went from 0 to key casting in less than an hour, plus like a 3-minute video that I watched. It was not very difficult to pick up. Like, practice makes decent on this, right? So as you can see here, we've got the quote-unquote finished key replica, and then we've got the normal key. And there's some defects with the key replica, as you can see here, but with wiggling it, I was able to overcome this, so it wasn't too bad. Mostly functional, right? Like, if I put it in, it doesn't turn immediately, but I just rock it back to fill up for that gap, and then should open right up. And there you have your key, right? These keys are very, very delicate. Remember, this is about 33% lead. So let's talk about crash bar hooks. The Sparrows one is bulky, and rubber has to be trimmed on it. You can make your own, and I recommend using titanium bars or steel bars. You can get these online. Realtor signs have wireframe that can be used, but they can't be hardened very well, so try to avoid this unless it's your last-ditch effort, and you can try to double up on the real estate sign and make kind of 2 wires going along, but it doesn't really work too well. Here's a hanger that I had in my room, and it was all metal, thankfully, so we lucked out on that speedrun tech, and that's the first 2 steps. I reinforced it with some Kevlar cord and the rest of the hanger, and then some gaffer tape. And this supports about 5 pounds of force on that hook point, whereas the Sparrows one is about 20 before it starts really bending. So it's give and take, right? Looking at this double door J tool, the humble firefighter has the instructions on how to make these properly. But as you can see here are the specifications. This would go in terms of your doors, it would go kind of through here and actuate the door from the outside, right? I think 3mm titanium is great. Shout out Rob Moore for that. He recommended titanium over steel. If you heat this, you want to heat it red, you want to bend it, and then you want to air cool it or sand quench it, and not do the whole water quenching, oil quenching. With steel, you want to do the quenching in water or use motor oil. With titanium, there is a spring back effect, so when you bend it, it's going to spring back normally. So if you're going for a 90-degree angle, you want to go a little bit more in terms of the bend, right? And you'll see the manufacturing here in a second. And I think audio hopefully is passed through. I don't know where I'm hearing the audio from, but I can just hear it faintly. Oh, yeah. But as you can see here, this is the titanium 3mm bars, and we just heat these up. I am not wearing gloves or ventilation equipment or shoes, proper shoes. Don't replicate this. This is, yeah. So you heat it red, you bend it, and once it's bent, you kind of let it sit there, or you do your sand quenching, right? Don't use wet sand. And the sand quench technique, that was actually, I found that on a phishing forum where people were talking about titanium wire and whatnot. So let's talk about forensics tools. Finding your keypad touches. You can have dust reacting to ultraviolet light, and this is suspicious procuring and traveling with. It's kind of like, how do you sell this off? If TSA is going to look at you weird, how do you get it past them? And it doesn't even get you high. Like, you paid $13, and like that's the only use it has, is finding fingerprints. Versus sucrose-based powder, which honey dust, pleasure-driven retailers have this all the time. It sticks to oils very easily. It's available at your pleasure-driven retailers, and it's cornstarch, baking powder, or powdered sugar types of alternatives. The thing is, honey dust has such a small granule size, it's amazing for fingerprints. I have tried baking powder in the past. I had tried powdered sugar in the past. Nothing comes close to honey dust and its ability to just stick to anything because it's so small in terms of that particle size. And you can see here, there are a couple techniques that we have, but clean-ish keypad, and we can see there are like no super visible fingerprints, whatnot. And I'm going to go ahead and just use it like a normal person would, right? I'm an authorized personnel typing in the code I know. Oh gosh. And as you can see there's already residual ridges from your fingers, and you can see that in the glimpse where that light reflects. And if we want to abuse that, we can just throw this powder at it, this honey dust powder with the feather applicator that comes with the device, and it stands out like crazy good, right? Like, you can see that a lot better. And you want to wipe the surface a little bit. You don't want to be too tough on it, right? Because you'll lose the fingerprints eventually. But with the feather duster, it's amazing. I've actually flown with a jar of this honey dust and that feather applicator in my carry-on to numerous states and have gotten no looks from TSA. I try to make eye contact. Anytime they're inspecting my bag, I will bait them and I will look at them. They're cowards. They don't look at me. I'll carry 2 of those bump hammers in my bag and the powder, They do not turn. There was one guy who was a TSA agent who just looked around frantically, and I was like, no, I'm right here. You know where I am. Look at me. Look at me. Here's a technique using a highlighter, a yellow highlighter, and a ultraviolet light, or a black light. And as you can see here, I'm just drawing little X's on it, little formation shapes. These are supposed to be interrupted by the fingerprints whenever people touch them. So this is kind of pre-rigging. Whereas the honey dust is investigating who touched what buttons on there. This is saying, oh, my target's going to come through this door and touch these buttons. Let me go ahead and prime this for use, right? So we've made the X's. And as you can see here, we've got the X's and they stand out pretty well. And we're going to go ahead and be our target, and we type these things in. And you can see the ridges just interrupt the portions of the X's. I have been told by coworkers that to use a non-smudge, or don't go for the non-smudge highlighters that are yellow. I tried other colors, but yellow highlighter is just the best. The others just don't work as well. Talking about door alarm bypasses, so K&J Magnetics, shout out them, they're cool, they have strong magnets, your neodymium magnets. The reason this is important is because when you're trying to get magnets through crevices and through small areas, you want the neodymium ones because they are stronger. There are normal magnetic paper sheets you can use, but they were just never strong enough to actuate what I needed them to in this device. You can also use the polarity detecting papers if you can't get one of these dipole magnet detectors around that area. So this is a lab environment, obviously, so it's like best case scenario, kind of proof of concept-y. As you can see, this is a huge magnet. So the process is essentially slip magnet between other magnets. That's it. And then once you've done that, you can't really hear the alarm go off because of the sound setup here, but it doesn't go off, and it's silent. Oh, cool, you can do whatever you want now. Go pen test all the things, right? And that's one technique you can do. Wow. So talking about HID, so this is a subject I'm not as strong as, but there are a lot of cool devices on the market nowadays. But starting out, I like to use the Arduino shields that came. There's the low frequency and the high frequency ones you can buy, and there's a lot of cool GitHub projects that do like MyFair 1K classic cracks and whatnot. You can brute force those keys, or do a dictionary attack against known keys. And this is a heavily talked about thing. There's the Chameleon Pro, which is cool, Flipper Zeros, and some other devices coming out. Great Scott has an awesome video on trying to extend the RFID range for some of these readers and going over the math and all the cool electrical engineering stuff I'm too dumb to understand. And basically just takes these eBay ones and is able to extend that range a little more by adding some capacitors here, changing the circuit, right? If you do buy these large coils that are meant for longer range reading, you do have to have pre-made keys normally for them. As you can see, that's like a low frequency one, but you would have to set it up properly so it negotiates with the car, the handshake. So talking about disguises, Goodwill is drip. Goodwill is awesome. Not as a company, but like what you can buy there. Some swag can be ordered, so your Walmart vest, you might see these go on sale on eBay before Black Friday. I'm not going to go into that. What I use recently is zinc printer. It's a type of paper where you'll see people have this Polaroid type setup. It's a small battery-powered device that fits in your hand, and you're able to use these pre-formatted sheets of paper to print pictures. And so here's the printer. And I say, oh, okay, like let me open like Snapchat editor or something and make my fake little picture. And this is the one I made for another presentation at a community college. And as you can see here, this just prints out in a matter of minutes, and you can just put it on any card. Now, upon really close inspection, you can notice, oh, it's not the exact same size as the card, but you can fill it in by printing a blank sheet of paper and filling it in, et cetera, changing things. If you do have these disguises where you have lanyards and whatnot, and your pretext says, oh, I've been here a while, then run those into the ground. Don't make them look new, right? You don't want to look like you just got back from the Kinko's, right? So yeah, wear them down. Sharpie's good as well. Talking about implants, your USB HID implants, rubber duckies are cool, but like, have you ever felt bad for leaving one at a site, like a $50 dongle or $75 dongle? You're gonna lose that because your PowerShell payload had to run? Really? These are $1. If all you need is HID emulation, then you can just run these and then leave them. Oh, okay, cool, I don't care I left that at a customer site. They can burn that, they can do whatever they want. It was only $1. There is previous research on the Weed suite, the Weed Elite suite, I suggest you go check that out. But if you will use a Raspberry Pi Zero W, you can have the PwnPy kit, which back in the day used to be a really cool kit that had like air gap bypasses and all this HID, mass storage emulation, could do a whole bunch of cool stuff. When you do that wiring, I wire it up so that these 4 connectors are all on the same USB port, and it's actually at a right angle. Some people buy the adapter, so it's your Pi and then the weird USB port, and it's a really long thing. But for a certain use case, I bent it 90 degrees and needed it so I could go up to a help desk, talk to the help desk person. They're using an all-in-one. I'm talking to them. Their all-in-one is right here. I plug it in, and it fits nicely because of that 90-degree angle. And then I leave and I get my shell, etc. You can also use Logitech dongles. These are about $7 each. And if you set these up, you can use a GitHub project to go ahead and just set up communications for keystroke injection for these HID implants. Talking about your network monitoring, network taps, Raspberry Pis got expensive, right? So using passive monitoring, I like the Orange Pi series, as long as they support Armbian, so you're not downloading some weird image off of GitHub. You want to spoof Mac usually as printers or Mac devices or VoIPs. Those are great devices to spoof. Now, do be warned, if you run into network access controls, et cetera, or you have some type of authentication, you might have to change this. It's not context aware, right? But you can add buttons as well. So for GPIO pins, you can add buttons that say, okay, start monitoring, start capturing packets. Okay, now exfil out. Okay, now do this. So they're great little platforms, and they're half the price of Raspberry Pis most of the time. And you have some here's some just lazy exfil methods, right? You can DNS tunnel, you can use like ngrok, Cloudflare, whatever to prove the point, right? You can purchase your LTE hats to do out-of-band stuff, whatever. Your powerless taps are error prone, so if you do a passive tap, right, that is going to drop a lot of packets, and it's also going to downgrade the connection to 100 base TX based on how it works. Don't ask me how it works. It's just I'm not an electrical engineer. I don't do that stuff. But no idea if you'll fry something if you get like an Ethernet port or PoE, et cetera. I've done it with PoE and it's worked fine, but mixed mileage, right? So as you can see there on my arm, that was at one point worth like over $500 when the Raspberry Pi spike started going up. So yeah, that's a flex. If you're going for active taps for gigabit connection monitoring, et cetera, you can buy these Wireshark taps that are like $230 and they look like a tap. Or you can use what they might already own in their network closet and just duplicate the port or mirror the ports or mirror 4 ports or do whatever you want, right? So try to blend in more with the environment. Talking about wireless, I personally think you should all stop using Wi-Fi pineapples. I'm not paid by anybody to say this, but like Linux plus BetterCap and 5 gigahertz cards go a long way with just being able to troubleshoot and do your own things. I've had Wi-Fi pineapples fail me quite a few times in very critical sections of the operation. Ponagachi is awesome. It's a great little starter kit. You can go and flash one of the 2 forks that's working now. Your antenna can give you different ranges. You all know about this probably much more than I do because I'm not a very big RF nerd. But do your research on what cards support what wireless stacks. So your hosting AP, bridging networks, and all that. You want to make sure that's all there. And take your full PCAPs during your wireless activities. Have a buddy take full PCAPs while you're doing your hacking and all that. And so you can deduplicate and say, yeah, that was me. I sent those packets. Or, oh, yeah, I stole that handshake, whatever. And here's just an overview diagram of a Yagi antenna. This is more directional, right? And it gets you longer range. And there's a CAN antenna as well. So check those out. So talking about practicing on your own, how do you practice on your own when you don't have access to these like red team environments and places that you're normally given a lot of authorization to via contracts? Well, if you're authorized to be on either side of a door, that's a great place to start. If you're focusing on info gathering, I think that's awesome. What you can do is you can be authorized for certain spaces and kind of dig in by asking or wandering around, right? And DEF CON's a great place for that. BSides a great place for that, right? Here's an example. So there was an auction for a gym that was nearby, and I said, oh, okay, they have an open house. Let's go to the open house, right? And I went to the open house, and I was just walking around and being nice to people, just checking things out. And you just like walk into places, and it's an open house, so it's open, right? Like you're supposed to be there. Granted, when I got to the network closet and like was walking around the keys, as I was walking out, they were like, "Oh, you're not supposed to be here." And I was like, "Oh, I just wanted to buy stuff." And they were like, "Oh, okay." And, went about your day. But always try to find more information about environments you're already in, right? That you don't own, hopefully. Here's a resources dump. I encourage you to check out all these resources. Physical security bypass games. Bosnian Bill has some great videos. Lockpicking the Lawyer, Deviant Ollam, Not So Civil Engineer has a great playlist. The Humble Firefighter, she has great respectful entry playlist that you can look at a lot of these tools on and more. So takeaways from this. Be resourceful. Become ungovernable. Once you've learned a concept, go back and do it with shittier tools for fun. Repeat this until you can do it with as minimal supplies as possible and do it under pressure, do it under duress. Stay out of trouble though, and I do help organize a conference in Wichita called OSSEC, so yeah, if you can, if you're in town around that date, those dates, October 18th, 19th, check us out. Well, I'll be there. And yeah, any questions? We've reached the end of the talk. Thank you, everybody, for your time.
Thanks. For the polymer clay key mold, do you bake the clay? Do you do it while it's still wet? Do you use air dry clay?
Awesome question. So don't use air dry clay. What I do is that Sculpey 3 clay is actually the baking kind, but I don't bake it, right? Yeah, because it'll shrink. So you'll notice when you pull it out of the mold, in terms of the texture, you'll pull this key out. Oop, went too far. You'll pull this key out, and essentially you'll see where the metal was residing on the clay. It's already kind of solid, right, and baked. So yeah, you don't want to bake it. You just want to get it hot enough. The Cerosafe I was working with melted at, I believe, 180 degrees Fahrenheit. So what is that, just under like boiling or something like that? So yeah, mileage may vary. Woods metal, I think, has a higher boiling point. But yeah, Cerosafe has varying boiling points. So yeah, don't bake it. Don't use air dry. Just use normal baked clay. Yep. Other questions? Don't be shy.
The magnet bypass for the magnetic alarms.
Yeah.
Does stuff like orientation of the magnet matter for most alarms, or can you just like shove it on there and it works?
Great question. So yeah, for this alarm that is $3 on Amazon, it does not matter the orientation, I found out later on. Normal magnets, like quality stuff that's sold to you by a vendor, yes, it does matter. And that's why you have this detector here, or you use your sheet of polarity paper to detect what polarity it is, because you want to essentially match the portion of the polarity that is off on the opposite side of this node, right? Or the opposite side of the node you're trying to not trip. So yeah, does that answer your question?
Yes, thank you.
Yep, cool. Other questions? All right there.
Have you encountered any door that has a piezoelectric door relay system at the other side, where you have to maybe use your underdoor tool to wave at it or actuate that piezoelectric sensor to open a door or something?
Oh, are you talking about the rec sensor, the request exit sensors?
Yeah.
Yeah, so your request exit sensors are normally, your cheaper ones are passive infrared, and they'll be very easy to trip. There have been some newer ones on the market that claim to do motion detection and human detection and all that, but they don't really get into the specs of how they do that. Obviously, there's got to be a way to fool these. But yeah, you can use canned air. There have been stories of people using blow-up dolls as well with a hair dryer and hot air on setting. You can get a hair dryer for, I think, $10. I got one at Walmart, was like the cheapest one, and the blow-up doll was like $50, which is crazy. You can buy 5 hair dryers for the price of one blow-up doll. But yeah, so you can trigger those passive infrared ones pretty easily as long as you're displacing enough temperature in the frame. So yeah, I actually recorded some video demos where I was browsing forums and I had seen people talk about putting Tupperware over them to just cover them if these are rigged to trigger something when they detect movement if you're trying to stay in an area. And that actually works pretty well as long as you're fast and you don't change the lighting too much in terms of variance. But yeah, passive infrared, people use CO2 cans as well. Davian Alam has a video of using small compressed CO2 cans. I think the air duster for computers is better because you get a flexible pretext. Like, oh yeah, I'm the IT guy, here's my fucking duster I use to clean your computers. Versus, oh, here's this weird thing that looks like a miniature bomb, right? Like in the palm of my hand. So does that answer your question? Cool. Other questions? If not, thank you all so much for coming out. Yeah, thank you for the time and really appreciate it.
All right, thanks, Angel. We got one more talk at 6 p.m. Stick around.
will I do for him? I'm just trying to give you something.
All right, last session of the first day of BSides 2024. Thanks for sticking with us here in ground floor. Before we get started, quick announcement. First of all, I'd like to thank our sponsors, especially our diamond sponsors, Prisma Cloud and Vanta. Gold sponsors, Project Circuit Breaker and Adobe. It is their support, along with other donors, volunteers, sponsors, that make this event possible. Because these talks are being streamed live, please turn off cell phones, or at least put them on silent. I will keep this mic for questions after. Please welcome Fabricio.
Hello, everybody. First of all, thank you, BSides, for having me here. I appreciate this opportunity. This is my first international conference, but I'm very nervous. Sorry because about my English. I don't know if you understand something that I will say here, but I'm here. Okay, today I'm going to talk about Windows Event Log and Persistent, and how you can use the Windows to create some persistent and exploit some vulnerabilities, okay? Okay, about me. My name is Fabricio Jimenez. I have 11 years old with offensive security. I have some certification that I don't like exactly certification, but I have OSCP, OSWE, CRTP. Also, I spoke in some conference in Brazil. Brazil is a very good place. If you visit Brazil, let me know. I can help you look around good place here, or good place there, sorry. Besides São Paulo, woohoo! No Bytes, ATC Echo Party. This is my LinkedIn, is my Twitter. Disclaimer, nothing I can say here represent my company. That all shit I will say represent is my responsibility, that's okay? Yeah, let me explain about this. In Brazil, it's very common the company use some talk to block the employees during the talk. And then the company maybe obligation was put this inside the talk. The motivation. My motivation about this talk, I love some techniques like privilege escalation and domain admin, principal Windows environment. And then during one internal engagement red team, I found a lot of vulnerability in Windows environment, but I found a difficult way to exploit and to create some persistent and again local administrator, something like that. About agenda, I will talk about red team attack simulation, PowerShell constellation language mode, custom run space and recon. This is a good feature that Microsoft created to help a blue team for improve the security environment. Practical privilege escalation. What the privilege escalation? Ours installer elevated and a new approach. Practical persistent. This is my preference techniques during the red team engagement. What the persistent and the Windows event log. Okay, before I start my talk, I would like talk about some phases during the red team engagement. My main goal here is explain about the recon. Recon is very good techniques and very good important techniques that we have during the red team engagement. Because during the recon techniques, we can find a lot of vulnerability and a lot of misconfiguration that we can exploit them. After that, the local privilege escalation is another good technique that we can look around. Because, as you know, during the red team engagement or pen testing, we need some user that have high privilege to do something that we cannot do with normal user. And to finally, we have the persistent techniques. This is a good thing. During the persistent technique, we have, before I explain this, in a lot of Windows environments, we have some ADR. The ADR is like a CrowdStrike or something like ADR. the block created some persistence. It's very important to you look around this because when you create some persistence with, for example, Windows task list, Windows Defender or CrowdStrike block this. And then in these techniques, I will use the new approach, Windows Event Log, to create a new persistence that the Windows Defender and the CrowdStrike won't detectable these techniques. Is very important. Okay, let's talk about constellation language mode. It's very complicated word, this. Okay, as I mentioned before, the constellation language mode, the Microsoft created the constellation language mode, I don't know how much years ago, but this is very good feature that Microsoft created. This feature help a lot of blue team and the sysadmin, whatever, to protect PowerShell environment. And then when the Microsoft created this feature, Microsoft look around, okay, I will create this feature to help some people, and my intention here is block wrong people executed bad script or wrong script inside the PowerShell. In this case, in the constellation languages, there are three different types in constellation language mode. The first type is full language mode. What means full language mode? Full language mode means that you can execute it, whatever you want inside the PowerShell, and then you can create in a reverse shell, we can create persistence, we can write the I'm hacker, and then the PowerShell does block you. The second type have in constellation language mode is constellation language mode. What means this? This feature does block you write something in PowerShell, but we can write a specific thing inside the PowerShell. The last one we have is restriction language mode. The restriction language mode block all the people, all the PowerShell script that you want execute this. Okay, there are many ways to enable the constellation language mode, but here I have two different, one type that you can use for enable this feature. The first one, as we can see here, we have I just executed the script in PowerShell to check if you have some blocks, okay? And then, as we can see here, we have full language mode. What means this? This means that I can write everything inside the PowerShell. If I want enable the constellation language mode, I can just write this string inside the PowerShell, okay? And with this word, constellation language mode. After that, if you execute the same script, the PowerShell return the constellation language mode is enabled. And then, if I write I'm hacker, the PowerShell block me, okay? But this is the problem. This is fast. This is easy way to enable the constellation language mode. But when you open the new session in PowerShell, we can bypass this because the constellation, this feature, this feature just working in the session PowerShell. If you open a new session, we can bypass this. Okay, in my opinion, during my researching, I found different ways to enable this feature. In my opinion, this way is a better way, okay? We can open AppLock to enable this feature, and then we can create this rule here. Deny PS1, about PowerShell. What means this? This means that you can block all script that you need executed in PowerShell, okay? Other way to enable the constellation language mode is through regedit. The RegoDit is good way, in my opinion. This will work for me. And then we can create a key environment. And then we can put inside this key with 4, sorry. Oh, yeah. Okay. A little explanation about run space. I don't know if everybody here know about the run space. The run space is a very good technique that Microsoft implemented inside the PowerShell. The run space working together with the PowerShell, and then if you open a PowerShell session behind the PowerShell, the run space working to execute some script. And then I will use the run space to bypass the constraintual language mode, okay? There are 2 different types of run space. The first type is local run space. This is our case, okay? Because this, during my engagement, I use the physical machine. The other type is remote run space. This is for the ones is not important because I will use just a local run space to bypass something. That's how you want. Okay, I'm not developer, okay, but my script working. In Brazil, we can name Frankenstein. The Frankenstein is the script that you created to help you during your engagement. This script, I created this script with C#. C# is very good language. You know? And then the first thing that I created was console write line. The Pudding user can do everything that you want. I love the Pudding. The Pudding is very delicious dessert have in Brazil. He's have too. And then after that, I will call some .NET application to install my script. And after install my script, I use another type to install. This is very important during my proof of concept because I don't use external tools. I just use .NET tools, okay? And then, okay, how I can execute some script, some bad script or some payloads without the defender blocking my execution or without the CrowdStrike block this. The first thing that you can do here is bypass the MSI. This is important. And then I created the first string. The first string call the remote machine that they are MSI bypass. After that, I use the power-up. The power-up is very good tool and powerful tool that help us to do something inside the machine. And after that, I create another string to bypass, to elevate the privilege and open the new session with local administrator. And here, I'd call the one space. As I mentioned before, the one space is important technique that we can execute it here. And then I will call the first string, FGP01, FGP02, and FGP03. Okay, as I mentioned before in my begin this talk, I use the constellation language mode, okay, to execute my recon and look around some techniques or some vulnerability that I have inside the machine to creating privilege escalation and create a new user or open a new session with local administrator, okay? In this case, as we can see, I use the certUtil to encode my payloads, okay? And then I encode my payloads like a certification. After that, I use the command inside the Windows, the bitadmin. The bitadmin is powerful tool to transfer my payload encoder in my remote machine, and I will save this payload in task encode.exe. After that, I use the certitude to decode this, save in Windows task. Why I save my script in Windows task? In majority of cases, the ADR or Defender don't look around in Windows tasks, just look around different folders. And then, okay, I save my encode.txt, and after I save it with exe bypass, and I use the .NET to install without log to install my payload. Okay, previous escalation, ours installer elevate in new approach. I don't know if you know about this vulnerability. This old vulnerability, approximately 10 years ago. But I found a new approach to elevated previous escalation with these techniques. Okay, but what is the previous escalation? Everybody know about the previous escalation here, but there are different types of previous escalation. In my opinion, Windows previous escalation is more sophisticated technique that we can use, and then we can exploit this. Ours elevate installers. What means water elevate while ours elevate installer? Ours elevate installer means that we can install MSI program inside the Windows with high previous user. What means this? This means that we can install the program or whatever you want with administrator, or you can create a local administrator and put this use in local administrator group, okay? Okay, as I mentioned before, I will use a new approach for this. There are one approach, the older approach in Metapreter. Metapreter, there are one payload that you can use for creating MSI program and install this, but I use Wix file. Wix file is like a XML file that you can create and can modify something that you want inside this file. And then in my case, here, I just creating a new PowerShell session. Okay, this is XML file, and then I open the new PowerShell session with a local administrator. Okay. Okay, what persistence? This is very good techniques. I love this because during the red team engagement, we can return our environment to do something that we cannot do in less time that we have do. Okay, let me explain here one thing. During my research, I found a lot of different techniques that create persistence. But in my opinion, when you're creating some persistence, for example, Windows task list or Regadit, something like that, the Defender or CrowdStrike can block you. And then, in this case, Defender don't look around Windows event log. The ADR don't block something inside this, okay? Windows event log. I will explain here about Windows event log. Everybody here know about this, but I will explain what difference between event log and application event log. The Windows event log is, the Microsoft created this to create some, if you execute some command inside the PowerShell or CMD, normally create a new event, okay? But Windows application event log is different, okay? For you create some Windows event application log, you need local administrator to do this. And then this is my approach, okay? I use my last previous escalation to create a persistent inside the Windows application log. Okay, Windows event log conceptual tool. Why I choose Windows application log? Windows application log, they are a lot of fields inside this. The first field have log key, source, date time, event ID, task category, level, computer, and event data. Event data in our case is very important because I use event data to create my shell code and create my reverse shell, okay? Oh yeah. Okay, after I executed my recon, I executed my previous escalation, I have a local administrator, and then I can create a new application, Windows application event log, with my shell code. First, I create my event log, the event log name POC Pudding, source Pudding, all the things. After that, I created the shell code with MS7 with X format, here as my payload. And then I need I need to put this shell code inside the Windows application log. And then I use the hash byte and replace some bad characters that Metapredator created for me. And then after that, I write my shell code inside the raw data, okay? The number event ID is, this number. The raw data is called the hash byte array. Sorry, I'm nervous. Okay, after creating Windows application log, I need to call this application log. This is Windows event application log. And I need to execute my shell code inside this Windows application log. As I mentioned before, I'm not a developer, and I create another script to help me. This script call my event log, okay? After that, this script called POC Pudding. This is my last event log I created. And then I need to read the raw data field. And then here I create the string to read this raw data. And of course, I need to use some Windows API, create thread, write thread, and virtual lock. This is common API in Windows. That's ADR look around this API. And a lot of Defender, for example, or CrowdStrike look around this API because this is very dangerous for the Windows. Okay. Let's go. Talk all the things. Okay, here we show about the constellation language mode. As we can see here, we have the consortium language mode enable. I'm a hacker. The consortium language mode blocked this line. Here I use the CertU to encode my payload, okay? Okay, here I use the bit admin to transfer my external payload to local machine. Okay, I need to wait. Yeah, here, let me. Okay, here we go. Yeah, here. As we can see here, we have encode, payload, MSI bypass, and power up. After some minutes, we have the recon result. As we can see here, we have our elevated installer vulnerable. Here we go. Here we have a new session with local administrator, user. I created a new application event log, putting all the things with my shell code. Yeah, this is important. As we can see, we have Defender enabled here. And Defender is a beautiful ADR Microsoft created, but unfortunately, the meta prioritization okay, important, important. During my research, I created a task, Windows task, because I want to execute this same script during 10 minutes or 5 minutes, okay? I have a shell. Here I'm nervous, I write shell, but I need to open the session first. Okay. Thank you. This is my official LinkedIn. If you want to talk with me, sorry. If you have some question, please let me know.
Any questions? Cool.
You're writing the shellcode to a event log. Most event logs are set up to eventually be deleted when they're filled up with other events. Is that a good idea? That's where you're placing your persistence.
Sorry, I'm not to hear you very well. Can you repeat, please?
Yeah, you're putting a shellcode in an event.
Yeah, right.
And normally event logs are set up to only have a certain amount of space. When they fill up with events, your event will be deleted.
Yeah, okay. In this case, I put the shellcode inside the Windows application log. And if you want to create another event, you can create another event with another name. And then you can put your shellcodes inside them again. I don't know if I understand correct your question, but this is the answer, okay? More question?
Okay. Thank you so much.
Thank you.
See y'all.